The liar paradox. What if I told you this sentence is false? You might smile, thinking it's just a clever play on words. But pause. Truly think. If the sentence is false, then it must be true. But if it's true, then it must be false. You've just stepped into one of the most ancient and unsettling riddles in all of philosophy, the liar paradox. The roots of the liar paradox stretch back over 2,600 years to a philosopher named Epimenides of Crete. He reportedly said, "All Cretans are liars," despite being a Cretan himself. His sentence became the seed of a logic problem that would baffle minds for millennia. Later, this evolved into a simpler and sharper version. This sentence is false. It looks innocent, harmless, but it quietly folds in on itself, like a snake eating its own tail. It's been explored by Aristotle, debated in medieval logic, reshaped in modern mathematics, and now it lives in philosophy, AI, and even the fabric of formal systems. Let's linger a little longer with this simple sentence. This sentence is false. You read it, you try to evaluate it logically. If the sentence is true, then what it says must be the case. But what it says is that it is false. So if it's true, then it's false. Now flip it. If it is false, then what it says isn't true. But what it says is that it's false. So if that's not true, then it's true again. We've walked in a circle, a paradoxical loop, a contradiction born not from the world, but from language turning back on itself. Why does this matter? Because it shows that our system of truth is vulnerable. It reveals a hole in classical logic, the kind we use in law, mathematics, and computers. Think of it like a machine trying to understand itself. When a sentence refers to itself, especially in a way that challenges its own truth, the whole system begins to wobble. This idea, self-referential, might sound abstract, but it's at the heart of some of the deepest developments in logic and math. For example, Kurt Gödel used a similar technique in the early 20th century to prove his famous incompleteness theorems, which showed that in any sufficiently powerful mathematical system, there will always be statements that are true but unprovable within that system. His trick? He constructed a statement that basically says this statement cannot be proven. Sound familiar? Even in computing and AI, this paradox isn't just a brain teaser, it's a warning. Think about a chatbot that tries to evaluate the truth of every sentence it processes. If it stumbles upon a liar paradox, it could fall into an infinite loop, forever stuck between true and false. Programmers must build safeguards against such circular traps. Some philosophers and logicians try to resolve the liar paradox by saying such statements are simply meaningless. But that feels like a dodge. If they're meaningless, why do they feel so meaningful? Why do they feel dangerous? Others try to build new types of logic, non-classical logics like paraconsistent logic or many-valued logic, where a statement can be both true and false, or neither. These systems are less tidy, but perhaps more honest, more reflective of the messy ways humans actually reason. And yet, the liar paradox doesn't just live in academia. You can feel it creeping into ethics, into psychology, into politics. Think of a person who says, "I'm always lying," or a political figure who says, "Don't believe anything I say." How do we deal with such statements? Are they disarming, dangerous, or simply empty? The liar paradox is a mirror. It shows us that the moment language becomes self-aware of, it can short-circuit. The very tools we use to build our understanding of reality, words, logic, reason, can tangle into knots we cannot untie. There's also something deeply human in it. We're creatures of stories. We use language to shape our world. But when the story talks about itself, when the storyteller becomes part of the tale, the whole stage begins to wobble. The liar paradox whispers a quiet truth. The closer we get to absolute certainty, the more fragile truth becomes. So next time someone says, "This sentence is false," but also, shiver, you've just stepped into a riddle that's haunted the minds of the greatest thinkers in history, and it's still not solved. The Sorites paradox. How many grains of sand does it take to make a heap? 1, 10, 1,000. If you remove just one, is it still a heap? At what exact moment does a heap become not a heap? The Sorites paradox is one of the earliest and most enduring riddles in logic. It was introduced by Eubulides of Miletus, a 4th century BCE philosopher, known for formulating several logical puzzles, including the liar paradox. The word Sorites comes from the Greek word soros, meaning heap. While it may seem like a simple word game, the paradox has profound implications about the vagueness of language, the limits of categorization, and the boundaries of truth. For over 2,000 years, it has remained a touchstone for debates in logic, philosophy of language, mathematics, ethics, and even artificial intelligence. Let's begin with a thought experiment. You're holding a single grain of sand. It's definitely not a heap. Now, imagine adding a second grain. Still not a heap. A third? A fourth? At which point do these grains magically transform into a heap? And here's the twist. If you agree that 1 million grains of sand make a heap, and you agree that removing just one grain doesn't stop it from being a heap, then what happens when you keep removing one grain at a time? Eventually, you're down to one single grain again. So, was it ever a heap to begin with? This is the Sorites paradox, sometimes called the paradox of the heap. It reveals a frightening crack in our language and logic. It's not about sand, really. It's about how we define boundaries in an infinite, continuous world. It's easy to brush it off. You might say, who cares, it's just semantics. But this paradox hits deeper. Consider the word bald. At what number of hairs is someone officially 100? 10? None? Or the word tall. Is someone who is 5'11" tall? How about 5'10"? At what exact height do we switch from short to tall? The problem is clear. Natural language is vague, yet we make precise decisions with it every day. Legal systems, medical diagnoses, ethics, all rely on categories that are fundamentally fuzzy. The Sorites paradox forces us to admit that our terms, our everyday words, are often ill-equipped to deal with the spectrum of reality. Most things in life aren't black or white. They're gradients, fading one into the next. Philosophers and logicians have tried to resolve the paradox in different ways. One approach is to deny the initial assumption, to say that there really is a sharp boundary, even if we can't find it. Maybe at 7,003 grains a heap exists, and at 7,002 it doesn't. But this feels arbitrary and artificial. Another approach is fuzzy logic. Introduced in the 20th century, fuzzy logic allows statements to be partially true. A collection of 50 grains might be 10% heap. A million grains might be 100% heap. This avoids the paradox but complicates our tidy binary world. There's also the epistemic view. It suggests there's a precise boundary. We just don't know it. Like how there's a precise temperature at which water boils at a specific pressure, even if we don't always measure it exactly. But again, it pushes the problem into the shadows. In ethics, this paradox can feel haunting. When does telling part of the truth become a lie? When does poverty become destitution? When does a habit become an addiction? Or look at artificial intelligence. Machine learning algorithms are built to classify things. Spam versus not spam. Cat versus dog. Cancerous versus benign. But where should they draw the line when the data exists in a blurred spectrum? Even in politics, it creeps in. When does a protest become a riot? When does surveillance become oppression and injustice? How many crimes does it take to brand someone a criminal? If one harmless action doesn't warrant punishment, do 100 harmless actions combined still deserve none? The Sorites paradox teaches us this. Boundaries are illusions we construct to survive complexity, and sometimes those illusions are the very things that break down under scrutiny. In real life, we make compromises. We draw fuzzy lines and pretend they're sharp because we need clarity to function. But deep down, we know the world doesn't work that way. The paradox is humbling. It reminds us that language is a map, not the territory. And when we mistake the map for the ground beneath our feet, we risk walking off a cliff we didn't even know was there. So the next time someone insists on a hard boundary, ask yourself, how many grains did it take to become a heap? You may not get an answer, but you will start seeing the world, people, decisions, arguments with more nuance. And maybe that's the point. The ship of Theseus paradox. If every piece of your body were replaced, your skin, your heart, your bones, even your thoughts, piece by piece, over time, would you still be you? This philosophical conundrum is known as the ship of Theseus paradox, and its roots trace back to Plutarch, a Greek historian and philosopher writing around the 1st century AD. He posed a deceptively simple question. Suppose a ship owned by the hero Theseus is preserved by replacing each of its wooden parts over time. When no original part remains, is it still the same ship? The thought experiment was recorded in Plutarch's Life of Theseus. But the puzzle didn't end there. Philosophers, from Thomas Hobbes to John Locke, and contemporary thinkers have all wrestled with it, expanding its implications far beyond ships, to human identity, the self, memory, and even modern technology like artificial intelligence and brain uploading. Picture a beautiful old ship, the ship of Theseus. Over the years, its wooden boards begin to rot. Slowly, one by one, the boards are replaced with new, stronger wood. Eventually, not a single original plank remains. Yet the ship still floats, sails, and carries the same name. People say, that's the ship of Theseus. But is it really? Let's make it even more complicated. What if someone collected the old planks as they were removed, every single one, and reassembled them into a ship that looks exactly like the original? Now we have two ships. Which one is the true ship of Theseus? This isn't just about ships. This is about identity through change, and how we define continuity, sameness, and essence over time. Let's apply this to a more familiar setting. You. Every few years, nearly every cell in your body is replaced. You are literally not the same collection of matter you were a decade ago. Your memories shift, your beliefs change, your habits evolve, your face ages. So, are you still you? Or, imagine this. A man slowly replaces parts of his vintage car, first the tires, then the engine, the seats, the windshield. Years later, it's a new machine. But is it the same car he bought when he was young? Now, imagine a robot. Its circuits are upgraded, its processor is changed, its casing gets redesigned. Eventually, the robot shares nothing with its original form, but it continues to operate on the same goals and memories. Is it the same being? Theseus' ship is just a metaphor. What the paradox is really asking is, what makes something itself? There are two main philosophical positions here. One is called continuity of form and function. It argues that as long as the ship continues to serve the same role and carries the same story, regardless of the parts, it's still the ship of Theseus. Similarly, you are still you, even if every atom in your body is different, because your life continues without interruption. But the other position is original matter. It says the identity of something lies in its physical components. If those are gone, so is the thing itself. According to this view, the rebuilt ship from the original planks is the true ship, and the continuously maintained one is just a replica. So which view is right? Philosophers have tried various solutions. Four-dimensionalism says objects extend across time like they extend in space, meaning both ships are temporal slices of the same entity. Bundle theory suggests that objects are just a collection of properties. As those properties change, the object remains as long as the bundle maintains its structure. Others suggest that identity is simply a mental construct. We choose what remains the same. In modern science, these questions are increasingly urgent. In neuroscience, we ask, if we replaced every neuron in your brain with a synthetic one that behaved identically, would your consciousness survive? In AI ethics, we ask, if we replicate someone's brain digitally, complete with their memories and personality, have we copied them or have we continued them? In law and medicine, questions about organ transplants, personality disorders, and even identity theft all tangle with this paradox. In religion and spirituality, this puzzle overlaps with beliefs about the soul, reincarnation, and resurrection. If a soul leaves one body and enters another, is it the same person? What if technology allows us to upload a soul? The ship of Theseus exposes something uncomfortable. Our intuition about identity might be wrong. We feel that something must either be the same or not the same, but what if that binary is too simple? What if identity is not a destination, but a process? A flowing river that never stops moving, yet somehow remains the same river even as new water flows through. This paradox also invites a more compassionate view of ourselves. We often cling to past versions of who we were. We resist change because we fear it erases us. But what if change is how we remain ourselves? What if, like the ship of Theseus, we are always rebuilding? One thought, one choice, one memory. Zeno's Achilles and the Tortoise. Imagine the great warrior Achilles racing a slow-moving tortoise. Achilles runs 10 times faster, so he gives the tortoise a head start. Logically, he should overtake it in seconds. But Zeno says he never does. How is that possible? How can a swift runner never catch a crawling creature? This is one of the most famous paradoxes proposed by Zeno of Elea, a Greek philosopher from the 5th century BCE. Zeno created a series of paradoxes to defend his mentor Parmenides, who argued that motion and change are illusions, that reality is one, unchanging and indivisible. Zeno's paradoxes were meant to show that our everyday understanding of movement leads to logical contradictions. Among these, the Achilles and the tortoise paradox remains the most puzzling. It was recorded by Aristotle and later revisited by countless thinkers from antiquity through the Enlightenment and into the modern era. Though it sounds like a whimsical thought experiment, this paradox strikes at the heart of mathematics, physics, and our very perception of time and space. Let's walk through the puzzle. Achilles gives the tortoise a head start, say 100 meters. By the time Achilles reaches the tortoise's starting point, the tortoise has moved ahead, perhaps just 10 meters. When Achilles runs that 10 meters, the tortoise has moved again, maybe 1 meter more. Each time Achilles reaches where the tortoise was, the tortoise has advanced. And though the distance gets smaller and smaller, the process seems infinite. Zeno's conclusion? Achilles can never catch the tortoise. Of course, in the real world, we know he will. We've all seen fast runners overtake slower ones. The contradiction here isn't about physics, it's about the logic of motion. When divided into infinite parts, Zeno's paradox hinges on the idea of infinite divisibility, that space and time can be split into smaller and smaller segments, forever. So Achilles must complete an infinite number of tasks to catch the tortoise. First reach point A, then B, then C, and so on. And here lies the trap. Can an infinite number of steps be completed in finite time? To Zeno, the answer was no. And if you can't complete infinite tasks, then Achilles never catches up. For centuries, this haunted philosophers and mathematicians. Until the development of calculus in the 17th century by Newton and Leibniz, there was no clear answer. Calculus introduced the idea of a limit, that an infinite series of smaller and smaller numbers can still sum to a finite value. Let's apply this. Suppose Achilles runs 10 times faster than the tortoise. The tortoise's head start is 100 meters. So in the time it takes Achilles to run that 100 meters, the tortoise moves 10 meters. Achilles then runs those 10 meters and the tortoise moves 1 meter. Then Achilles covers that meter and the tortoise moves 0.1 meters, and so on. The total distance Achilles runs is 100 plus 10 plus 1 plus 0.1 plus 0.01 plus. This is a geometric series and it converges. The total sum approaches a finite number, about 111.11 meters. So Achilles does catch the tortoise, and in a finite time. Zeno didn't have access to modern calculus, so the paradox was left unresolved in his time. But what he did have was insight into the conceptual cracks in how we understand space, time, and continuity. Zeno's paradox isn't just about movement, it's about the limits of logic when applied to the real world. It forces us to question whether motion is something real or something our minds construct. And in doing so, Zeno indirectly inspired the development of modern mathematics. But even with calculus, the paradox remains symbolically potent. In the digital age, think of computer simulations. In video games, characters move in discrete steps, frames per second. Yet, to our eyes, they seem to move smoothly. Is motion continuous, or just an illusion of continuity? In quantum physics, the question becomes more pressing. Is the universe fundamentally smooth, or is it granular, made up of indivisible chunks of time and space? Zeno's paradox re-emerges when we try to unify quantum mechanics and general relativity. The math doesn't quite fit, just like the logic in the paradox doesn't. We're still seeking the deeper rules that govern reality. And in human psychology, there's something relatable in the idea of never catching up. Ever feel like you're always chasing a goal, reaching for something just out of reach? Every time you make progress, the target moves slightly forward. The paradox becomes metaphor. The chase itself is infinite. But there's also comfort in the resolution. Yes, the chase is made of infinite steps. But yes, you can still get there. Zeno showed us that infinity isn't just vast, it's strange. That dividing things into smaller and smaller parts doesn't always make them simpler. That sometimes to understand motion, we have to stand still and think. So when Achilles finally passes the tortoise, he doesn't just win a race, he breaks through a wall that's puzzled minds for centuries. And we're all running behind him, trying to catch up to understanding. The grandfather paradox. Imagine you invent a time machine. You travel back in time, find your grandfather before he ever meets your grandmother, and you kill him. The moment he dies, so does your future, because you were never born. But if you were never born, then who just pulled the trigger? The grandfather paradox, despite sounding like science fiction, is one of the most important and enduring thought experiments in philosophy and physics. It doesn't originate from one specific philosopher like many classical paradoxes, but it gained prominence in the 20th century with the rise of science fiction and Einstein's theory of relativity, which introduced the idea that time is not a fixed, universal constant. The term grandfather paradox itself became widely known thanks to speculative fiction writers and theoretical physicists. It's been debated by philosophers of time, by logicians, and by physicists like Stephen Hawking, who once suggested that the absence of time travelers from the future might be the best evidence against the possibility of time travel. But beyond fiction, the paradox raises real questions about causality, determinism, and whether time is a line, a loop, or something far stranger. You build a time machine, say in the year 2080. You step into it and program the year 1950. You appear on a street where your grandfather is a young man, perhaps just a teenager. You follow him, and then, in a fateful moment, you kill him before he ever meets your grandmother. That single act, simple in its brutality, erases your own existence. Because if your grandfather never lives to father your parent, then your parent never lives to birth you. So you were never born. And if you were never born, then how did you go back in time in the first place? That's the paradox. It's a causal loop that collapses in on itself. In normal cause and effect thinking, a cause precedes an effect. But here, the effect, your time-traveling action, changes the cause, your own origin, which undoes the effect, creating a logical contradiction. Let's look at some proposed resolutions. 1. Time travel is impossible. Chronology protection hypothesis. Physicist Stephen Hawking proposed that the laws of physics might prevent time travel to the past in order to protect causality. He called this the chronology protection conjecture. According to this view, some unknown mechanism, perhaps quantum in nature, would prevent paradoxical situations from ever arising. Maybe the time machine simply fails to start, or you can never reach your target. In essence, reality protects itself. 2. Multiverse theory, many worlds interpretation. Another popular resolution comes from quantum physics. According to the many worlds interpretation, each decision branches into a new universe. So when you kill your grandfather in 1950, you don't erase your own timeline. Instead, you create a new timeline, an alternate universe where your grandfather died early and you were never born. But in your original timeline, he lived and you were born. You just left that one behind. This idea, though mind-bending, removes the contradiction entirely. You're no longer affecting your own past. You're creating a new future in another dimension. But here's the twist. It implies there are countless versions of you, all branching off in different realities. And once you leave your own, you can never go back. 3. Novikov. Self-consistency principle. Named after Russian physicist Igor Novikov, this theory suggests that any actions taken by a time traveler were already part of history. In other words, you can't change the past. You can only fulfill it. So if you go back in time to kill your grandfather, something will always prevent it. The gun jams, you change your mind, you kill the wrong person, or perhaps your grandfather wasn't your biological ancestor at all. History finds a way to stay consistent. You can influence the past, yes, but never in a way that changes the outcome, because the outcome already includes your interference. It's a closed loop, not a broken one. But what if? What if we entertain the paradox at face value? No multiverse, no protective principle, no consistency clause. Then we're left with something unsettling. The idea that causality can break, that a future event can undo its own cause, that time is not a one-way arrow but a tangled web where loops can trap logic itself. It also challenges the concept of free will. If you can choose to travel to the past and act freely, yet your actions erase your ability to choose, do you really have freedom at all? Or, perhaps, time travel is possible, but only to observe, not to change, like standing behind a glass wall, watching the past but never touching it. Cultural impact. The grandfather paradox has become a staple of storytelling, from Back to the Future to Looper, from The Terminator to Dark. In each case, the plot hinges on how actions in the past ripple forward, or whether they are even allowed to ripple at all. But the most disturbing aspect isn't the murder, it's the disappearance. If you erase your own existence, what becomes of the moment you pulled the trigger? Does time glitch? Does it rewind? or does reality itself collapse? This paradox serves as a reminder that time, for all its familiarity, is still one of the greatest mysteries we face. We move through it, we measure it, but we don't understand it, not completely. And the moment we try to bend it, to step backward through it, we find ourselves at war with logic itself. So if you ever dream of going back in time, ask yourself one thing: can the past survive your present? Because if not, maybe you won't either. The barber paradox. There's a barber in a village. He shaves every man who does not shave himself, and only those men. One day, a villager asks, does the barber shave himself? The answer? It breaks logic in half. The barber paradox was formulated by the British philosopher and logician Bertrand Russell in 1901. He used this seemingly simple riddle to expose a deep problem in the foundations of set theory, an issue that would eventually become known as Russell's paradox. In his original form, Russell wasn't talking about barbers at all. He was trying to answer this: can there be a set of all sets that do not contain themselves? The innocent-sounding question caused a crisis in mathematics and logic. To make it easier to understand, Russell rephrased the issue using the story of the barber. Let's set the stage. In a small village, there is one rule that everyone follows. The barber shaves all those men who do not shave themselves. He does not shave anyone who does shave themselves. So far, so good. Now ask the critical question: does the barber shave himself? There are only two possibilities, yes or no. Let's say the answer is yes. The barber shaves himself. But by the rule, he only shaves those who do not shave themselves. So if he shaves himself, he must not shave himself. Now, suppose the answer is no, he does not shave himself. But again, by the rule, the barber shaves all those who do not shave themselves. So if he does not shave himself, then he must shave himself. In both cases, we hit a contradiction. No matter what, the logic eats itself. This is the essence of the barber paradox, a self-referential loop that cannot be resolved. It's not just confusing, it's logically impossible under the rules given. Russell used this to point out a flaw in naive set theory. Imagine you try to create a set of all sets that are not members of themselves. If this set contains itself, it violates its own rule. But if it doesn't contain itself, then it should contain itself. A loop, just like the barber. Before Russell, set theory was thought to be a pristine foundation for all mathematics, but his paradox showed it wasn't as clean as it seemed. The implications were massive. To fix the issue, mathematics had to rebuild itself from the ground up. Formal systems like Zermelo-Fraenkel set theory were developed with strict rules to avoid such paradoxes. But the barber didn't retire. Self-representation continued to haunt logic. Think about software systems that analyze their own code, or artificial intelligences trying to assess their own behavior. Even legal systems. Can a law rule on the validity of itself? The barber paradox isn't just about barbers. It's about systems folding in on themselves. And once that happens, unless you have new rules, it becomes impossible to untangle. In philosophy, this paradox echoes in questions of self-awareness and self-governance. Can a mind fully understand itself? Can a society write rules that govern their own evolution? Even in popular culture, these loops show up. Think of recursive jokes, paradoxical signs that say, ignore this sign, or statements like, I always lie. They reflect the same glitch in logic, when something includes itself in its own definition, and it gets more personal. Ever try to fix your own broken mindset with that same broken mindset? It's like being the barber and asking whether you should shave yourself or not. The only escape is to step outside the system, to redefine the terms, to write a new rule book. Bertrand Russell didn't just tell a riddle. He exposed the fact that even logic, the most precise tool we have, can fall apart when turned inward. The barber reminds us, if the rules don't make sense for everyone, they might not make sense for anyone. So, does the barber shave himself? Only if someone rewrites the story. The omnipotence paradox. Can an all-powerful being create a stone so heavy that even they cannot lift it? If yes, there's something they cannot do. If no, there's still something they cannot do. So can absolute power even exist? The omnipotence paradox dates back centuries, emerging from deep theological and philosophical debates about the nature of divine power. It appears in medieval Christian philosophy, Islamic Kalam discourse, and even earlier in Greco-Roman thought. One of its earliest formal discussions came from Thomas Aquinas, the 13th century philosopher and theologian. He addressed it in his Summa Theologica, asking whether God's power could include logical contradictions. Later, Enlightenment thinkers like René Descartes and Leibniz grappled with it again, trying to define what omnipotence truly means. Today, the paradox isn't just about religion, it's a modern puzzle used in metaphysics, logic, AI, and systems theory, anywhere the limits of ultimate control are questioned. Let's begin by posing the challenge at the heart of this paradox. Can an omnipotent being create a stone so heavy that it cannot lift it? This question seems simple, even playful, but the more you think about it, the more it begins to implode. Let's consider the two possible answers. Yes, the being can create such a stone, but now there's something the being cannot do: lift the stone. So the being is not all-powerful. No, the being cannot create such a stone. But then again, there's something the being cannot do: create the unliftable stone. Still, the being is not all-powerful. In both cases, the being fails. Whether it's lifting or creating, there's something beyond its reach. And so, we're left to wonder, is the very concept of logically impossible? This is the omnipotence paradox. It's not really a question about rocks or lifting weights. It's about the limits of power, specifically whether unlimited power is even coherent. Some philosophers argue that the paradox is linguistic, a trick of language, that the sentence, "Can an omnipotent being create a stone so heavy it cannot lift it?" is self-contradictory, like asking, "Can a square be round?" or "Can 2 + 2 = 5? In this view, true omnipotence doesn't include doing the logically impossible. Creating a stone too heavy for an all-powerful being is simply a meaningless task, not a limit of power. This was Aquinas' answer. He said that God can do all things that are possible within logic, but not things that are inherently contradictory. To him, God cannot make a square circle was no more a flaw than saying God cannot make a married bachelor. The problem isn't God, it's the language. But others like Descartes disagreed. He argued that God is so powerful that even logic itself is subject to divine will. If God wanted 2 + 2 = 5, then by sheer divine command, it could. This leads to a frightening idea. If logic can be broken by power, what can we rely on? Even today, the paradox remains relevant in secular discussions. In computer science, we might ask, can a program write code so complex that it can't debug itself? In AI ethics, can a self-improving system design rules it cannot override? If so, is it still autonomous? In government, can a system create laws it cannot break or reverse? If not, can we call it sovereign? In psychology, can a person set a rule for themselves they cannot betray? And if they break it, does that mean they were never truly in control? The paradox challenges the idea of self-limiting power. If a being limits itself, even voluntarily, is it still all-powerful? There's a modern interpretation of omnipotence that offers a path out. Some thinkers suggest redefining omnipotence not as being able to do anything, but as being able to do everything that can be done. In this sense, power is bounded by possibility, not by the will of the being, but by the structure of logic itself. This would mean that asking whether an omnipotent being can create an unliftable stone is not a real question, it's a logical nonsense dressed up like a challenge. Others take a different view. Maybe the paradox isn't about power at all. Maybe it's about the tension between creation and consequence. If you create something, an idea, a rule, a world, it begins to have its own nature. And that nature might include limitations. Once the stone exists, it has mass, weight, gravity. To make it unliftable, even to yourself, is to cede control to the object itself. In other words, true creation always involves risk. And perhaps that's the deeper point. Whether we're talking about divine beings, artificial intelligence, governments, or even our own minds, absolute power always confronts its own reflection. The omnipotence paradox reminds us that power isn't just the ability to act, it's also the ability to face the limits of what action means. It whispers, what you can do is less important than what you're willing to be accountable to. So, the next time someone claims they have total power, ask them, can you build something you no longer control? And watch their answer. The unexpected hanging paradox. A judge tells a prisoner, you will be hanged at noon on one weekday next week, but it will be a surprise. You won't know the day until the executioner comes for you. The prisoner thinks carefully and concludes the hanging can't happen. But when it does, he's shocked. This chilling puzzle, known as the unexpected hanging paradox, was first formally introduced in the 20th century, but its roots stretch into earlier philosophical thinking on self-represent, prediction and logic. It gained major attention after it was published by Martin Gardner in 1943 and later became the subject of intense debate in academic philosophy, mathematics and even legal theory. It is sometimes also called the surprise examination paradox, as it appears in the form of a surprise test scenario. At its core, this paradox is not about execution, but about expectation, knowledge, and the very nature of surprise. It demonstrates how our logical reasoning can break down when dealing with self-referential predictions. Let's go back to the scenario. A judge informs a prisoner, "You will be hanged at noon on one weekday next week, Monday through Friday, but the day will be a surprise. You will not know the day of your hanging until the executioner appears at your cell door." The prisoner begins to reason. Well, he thinks, the hanging can't happen on Friday, because if I'm still alive by Thursday night, then only Friday remains, so I'd expect the execution on Friday, and that wouldn't be a surprise. So Friday is eliminated. Now, he continues, if Friday is ruled out, then the hanging also can't happen on Thursday. Because if I'm still alive by Wednesday night and I know Friday is out, then Thursday would be the only option left. That wouldn't be a surprise either. He keeps going, ruling out Wednesday, then Tuesday, then Monday, each for the same reason. Eventually he concludes the hanging cannot happen at all. He smiles. He believes he's outwitted the judge. But then, on Wednesday at noon, the executioner arrives, and the prisoner is genuinely surprised. That's the paradox. How could the prisoner have logically ruled out every day and yet still be wrong? How can something that seems logically impossible still happen? This paradox reveals the fragility of logical reasoning when applied to predictions that refer to themselves. Let's break it down. The judge's statement is a kind of self-referential future event. It says something about how it will be known, or rather not known, by the person it affects. The prisoner uses backward induction, a method of reasoning where you start from the last possible event and eliminate it, then eliminate the second last, and so on. And his logic, step by step, seems sound. But the end result is clearly false. He is executed, and he is surprised. So where did the logic go wrong? Some philosophers argue that the prisoner makes a mistake by assuming that his reasoning itself is infallible, that if he logically concludes something can't happen, then it cannot, but reality doesn't follow his logic. Others argue that the judge's statement is self-contradictory, that a hanging cannot both be scheduled and remain a surprise. So the real paradox isn't the execution, it's in accepting a premise that is flawed from the start. Still others claim the judge's statement is actually true, but only because the prisoner's logic breaks down the moment he begins making assumptions about his own knowledge of the future. This takes us into deeper philosophical waters. What does it mean to know something in advance? Can we truly predict our own reactions? Let's apply it to a more common situation. Imagine a teacher announces, there will be a surprise test next week. The students, using the same backward logic, decide the test is impossible, but on Wednesday morning the teacher walks in and hands out papers, and the students are stunned. This version, called the surprise test paradox, has been used to illustrate how metacognition, thinking about thinking, can fail. When you try to anticipate surprise, you can paralyze yourself with reasoning. In legal philosophy, this paradox has been used to discuss punishment, expectation, and justice. If someone knows they will be punished, but not when, is that crueler or kinder? Is justice still served if it arrives unexpectedly? In computer science, the paradox appears in recursive reasoning, when programs or agents try to predict their own outcomes or the outcomes of others like them. In AI safety, this can become a serious issue. If an artificial intelligence tries to model its own decision process and predict future inputs, it might stumble into logical traps just like the prisoner, assuming some actions are impossible because they would no longer be surprising. Even in psychology, this paradox tells us something deeply human. When we try to predict the future, especially to avoid pain, we may build mental traps that only make the pain worse when it arrives. The unexpected hanging paradox is not about hangings. It's about the mind. It's about how we respond to uncertainty and how easily logic can become a cage. Because sometimes, the more we try to control the unknown, the more surprised we'll be when it arrives. And so, the prisoner's final thoughts, are not of justice or fate, but of confusion. How did logic fail him? How did the truth hide behind reason? Perhaps some mysteries can't be solved until they happen, and maybe that's the most surprising truth of all. The paradox of the stone. Can an all-powerful being create a stone so heavy that even they cannot lift it? If yes, they're not omnipotent. If no, they're still not omnipotent. But what if this riddle isn't about rocks or strength, but about the limits of meaning itself? Closely related to the omnipotence paradox, the paradox of the stone specifically zeroes in on one vivid mental image: a god or being of ultimate power, challenged by the very consequence of that power. While the idea may sound like it belongs in a fantasy novel or theological debate, this paradox is used across philosophy, theology, logic, and even AI ethics to test the coherence of limitless ability. Its earliest recognizable form is discussed in medieval theology, particularly by Christian thinkers like Thomas Aquinas, who argued for a rational structure to God's power. Later philosophers such as René Descartes, George Mavrodes, and modern analytic philosophers explored variations of the paradox, attempting to resolve or reinterpret it. It continues to be one of the most quoted examples in introductory philosophy classes because it seems so simple, yet breaks the very framework of logic when examined deeply. Let's revisit the question. Can a being with unlimited power create a stone so heavy that even they cannot lift it? Let's walk through both possible answers. Yes, the being can create such a stone, but then the being can't lift it. So there's something the being cannot do? Lift the stone. That contradicts omnipotence. No, the being cannot create such a stone. But then again, there's something the being cannot do: create the unliftable stone. Again, omnipotence is violated. Either way, the being's omnipotence is compromised. This is what makes the paradox of the stone such a powerful mental trap. It feels like there's no escape, but it's important to understand why it traps us. The paradox plays on self-referential contradiction. It asks a being to perform a task that results in their own limitation. It's like asking a painter to paint something they can never repaint, or asking a programmer to write code that they themselves cannot ever alter. At the heart of it lies a deeper question. What does omnipotence really mean? Does it mean the power to do absolutely anything, including the logically impossible? Or does it mean the power to do all things that are logically possible? This distinction is vital. Some thinkers, like George Mavrodes, argue that the stone paradox presents a nonsensical challenge, much like asking whether a being can create a square circle or make 1 + 1 = 3. These aren't tasks, they're contradictions. They don't make sense, even to describe. So, if the idea of an unliftable stone created by a being that can lift all things is inherently incoherent, then the question collapses under its own weight. The fault, then, isn't in the power of the being. It's in the language we use to pose the challenge. Think of it like a glitch in a computer. You enter a command that refers to itself in a loop, and the system crashes. Not because the system is weak, but because the command was malformed. This leads to a refined definition of omnipotence. A being is omnipotent if it can do anything that is logically possible and coherent. According to this, creating a stone so heavy it cannot be lifted by an omnipotent being is not a logically possible task, because it relies on contradictory assumptions. But not everyone agrees. Some philosophers, like Descartes, claim that if a being is truly omnipotent, it should be able to violate logic itself. That logic is just one more creation of the divine, meaning it could be redefined, rewritten, or abandoned. This opens a terrifying door. If logic can be violated, then nothing is stable. Truth collapses, math dissolves. The idea of what is becomes what might be, what isn't, and what cannot be, all at once. In this chaotic universe, the stone could exist, and not exist, and weigh everything and nothing. But few thinkers are comfortable with this level of radical omnipotence. Most believe that meaningful power is bounded by meaningful structure, that to say a being can do anything must exclude the nonsense. There's another perspective too, one rooted in linguistic analysis. The question, can a being create a stone so heavy it cannot lift it, looks like a regular sentence, but when analysed it lacks semantic coherence. It combines conditions that logically cancel each other out. It's like asking, can a being be both totally invincible and totally destructible? Or can a being be infinitely silent while shouting the loudest scream? These are not limits of ability, they are limits of formulation. From a computational or AI standpoint, this paradox mirrors the problems of recursive programming or circular functions. Asking a program to process itself, especially in a self-contradictory way, can lead to a crash or an infinite loop. So, if we design artificial intelligences and grant them higher-order control, must we build logical boundaries into their capabilities? Must power always be contained by reason? Here's another twist. What if the true mark of omnipotence is the ability to choose not to exercise it fully? Imagine a god who can create the unliftable stone, and can lift it too, but chooses to respect the logic and laws of reality to sustain the world. This interpretation reframes omnipotence as discipline, not chaos, as wisdom, not brute force, as the power to limit oneself, not because one must, but because one can. The paradox of the stone leaves us with a haunting conclusion. When we think of ultimate power, we imagine endlessness. But perhaps true power lies not in doing everything, but in choosing wisely what not to do. And maybe, just maybe, some questions are better left unasked, because the only thing heavier than the unliftable stone is the logic we use to create it. The bootstrap paradox. A scientist receives a book from a mysterious visitor. Years later, the scientist publishes that book as their own. Decades after, they travel back in time and hand the very same book to their younger self. So, who wrote the book? The bootstrap paradox, also known as a causal loop, is a relatively modern puzzle that emerged alongside the rise of time travel fiction, Einstein's theory of relativity, and questions about closed time-like curves in physics. The name bootstrap comes from the phrase pulling oneself up by one's bootstraps, meaning to perform an impossible task. This paradox gained popularity through stories, films and TV shows such as Doctor Who, The Time Machine and Predestination. But its implications go far beyond entertainment. At its core, the bootstrap paradox asks a chilling question. Can something exist without an origin, without ever being created, just caught in an eternal loop of cause and effect? Let's walk through the scenario step by step. Imagine a young physicist. One day, an older stranger knocks on their door and hands them a thick manuscript, a brilliant, groundbreaking book on quantum mechanics. The physicist studies it, builds a career around it, and in time publishes it under their own name. Years pass. The physicist grows old. Eventually, they build a time machine and decide to travel back to the day they first received that book, and they hand it to their younger self. The loop is closed. The question is, who wrote the book? Not the younger physicist. They just received it. Not the older physicist. They simply passed it back. There's no point of creation, no origin, just an infinite loop. That's the bootstrap paradox. It creates a world where an object, a piece of knowledge, or even a person exists without a beginning, a self-sustaining echo, a ripple without a stone. This breaks our most basic intuitions about causality, the idea that everything has a cause, that events follow one another like dominoes. But in a bootstrap loop, the dominoes form a circle. There's no first push, no source, only motion. Let's explore other versions. A time traveller goes back in time and gives Shakespeare the manuscript of Hamlet. Shakespeare publishes it. Later, the time traveller finds the book in a library and brings it back to Shakespeare. Who actually wrote Hamlet? A violin appears in a time machine. A young musician plays it, becomes famous, grows old and sends the violin back in time. Who made the violin? A baby is left on a doorstep with a note. The family raises the child, who later discovers time travel and leaves a baby on the same doorstep years earlier. Where did the baby come from? In each of these, the loop sustains itself, but lacks a foundation. Philosophically, this raises massive questions about identity, authorship, and existence. If something can exist in a loop without a cause, then what is creation? What defines originality? Is time linear, or can it fold, allowing effects to create their own causes? In physics, this intersects with the concept of closed time-like curves, CTCs, theoretical paths in space-time that loop back on themselves. Some interpretations of Einstein's general relativity allow for such loops under extreme conditions, like near black holes or in the hypothetical structure of a wormhole. In this context, a bootstrap paradox isn't logically impossible, it's just deeply unsettling. Some physicists, like Kip Thorne, have explored how information might travel through a loop without breaking the laws of physics. If the loop is stable, meaning the events don't contradict each other, it might be possible. But that opens the door to a universe where some things just are, without ever having been made. Think of the implications for knowledge. If an idea appears in the mind of a time traveler, and they give it to their younger self, where did it originate? Could a future AI invent something, feed it back to its creators, and cause a loop of invention with no starting point? Could consciousness itself be caught in a bootstrap? Some try to solve the paradox with the Novikov self-consistency principle, which says, only those actions that are self-consistent with the timeline can occur. So if the book exists in a loop, it always existed. It never needed an origin. But this sounds more like a narrative trick than a true explanation. We're still left with something that violates our sense of how the universe works. There's also a deeper, more personal layer. What if you exist in such a loop? What if your thoughts, your purpose, your memories aren't truly yours, but echoes of echoes? Passed from future to past, preserved only by the fact that they already happened. This is what makes the bootstrap paradox so haunting. It doesn't just bend time, it bends meaning. Because if something can exist only because it exists, if reality can sustain itself without a beginning, then perhaps nothing truly begins. And perhaps that's the most terrifying idea of all. Not that we came from somewhere, but that we didn't. The raven paradox. You want to prove that all ravens are black. You see a black raven. Good. That confirms the rule. But then you see a green apple. Strangely, that also confirms the rule. Wait, how can a green apple prove something about black birds? The raven paradox, also known as Hempel's paradox, was proposed by German philosopher Carl Gustav Hempel in the 1940s. As a challenge to the logic of scientific confirmation, it explores how we gather evidence, how we interpret observations, and what it really means to support a universal claim. It's a paradox that arises not from contradiction, but from something more unsettling, logical consistency that defies our intuition. It's been discussed in philosophy of science, epistemology, and probability theory, and continues to be a staple of how we question the reliability of inductive reasoning, the foundation of most empirical science. Let's start with the universal statement. All ravens are black. This is a statement of universal generalization. To verify it, you must gather positive evidence. Examples of black ravens. So you go out, observe hundreds of ravens, and all of them are black. Each sighting strengthens your confidence in the hypothesis. Now flip the logic. All ravens are black is logically equivalent to all non-black things are not ravens. This is a classic move in logic, called the contrapositive. So, every time you observe something that's not black, like a white shoe, a red car, or a green apple, and it's not a raven, you've technically confirmed the contrapositive, which means you've also confirmed all ravens are black. And here's the problem. You just strengthened your belief in the color of ravens by looking at a piece of fruit. That's the raven paradox, because according to formal logic, a non-black, non-raven, like a green apple, supports the same claim that a black raven does. It feels absurd. Your intuition screams, no, looking at apples has nothing to do with birds. But your logic says, yes, it confirms the contrapositive. This clash between formal reasoning and human intuition is what makes the paradox so powerful. Let's take an example. You observe a black raven, clearly supports all ravens are black. You observe a green apple, supports all non-black things are not ravens, and thus supports the original claim. But it feels wrong, because confirmation should be stronger when the object is directly related to the hypothesis. This paradox pushes us to consider what counts as meaningful evidence. Some philosophers argue that not all confirmations are equal. While both the black raven and the green apple are logically valid, the black raven has greater relevance to the hypothesis. It speaks directly to it. Others propose a Bayesian interpretation, where confirmation is tied to probability. Observing a black raven increases the probability of the hypothesis far more than a green apple ever could. But this raises further questions. If all confirmations aren't equal, then how do we weigh them? And if irrelevant confirmations technically exist, should we include them in our reasoning at all? This paradox isn't just a curiosity, it haunts scientific method itself. Every time you build a theory and try to support it with observations, you're relying on induction. assuming that what you've seen applies to what you haven't. The Raven paradox exposes how even that method can produce counterintuitive truths. It also pokes at the way we structure categories. If our concept of Raven includes abstract logical rules, then maybe everything that isn't a Raven becomes part of the evidence set, however meaningless that may seem. Here's another layer: confirmation bias. We tend to notice evidence that supports our beliefs and ignore what doesn't. The Raven paradox flips this upside down. It says we're missing supporting evidence every time we overlook the non-Beck, non-Ravens around us. A cup of coffee, a yellow pencil, a grey cloud. Each one technically whispers, "I'm not a raven, and I'm not black." The pattern holds. It's a quiet, unending chorus, and yet we barely notice it. This paradox reminds us that truth and usefulness are not always the same, that logic, while powerful, can be detached from meaning, and that sometimes even a green apple might tell us something about the feathers of a bird we've never seen. So next time you see something ordinary, something irrelevant, ask yourself, is this noise, or is it evidence in disguise? Because in a world ruled by logic, even silence speaks. The lottery paradox. You hold a lottery ticket. The chance of winning is 1 in a million. Logically, it won't win, but someone's ticket must. So how can it be rational to believe every ticket will lose when one of them is guaranteed to win? The lottery paradox was introduced by philosopher Henry E. Kaiberg Jr. in 1961 to challenge the way we think about rational belief in the face of high probability. It doesn't ask whether lotteries are fair or rigged. It asks something deeper. What does it mean to believe something is true when it's almost certainly true, but not guaranteed? It's a paradox about reasoning, probability and contradiction, and it touches on logic, epistemology and artificial intelligence. It reveals a strange conflict between three things we typically assume work well together: believing things that are very likely, avoiding contradictory beliefs, being logically consistent. Turns out, those things don't always fit in the same room. Let's paint the scenario. Imagine a lottery with 1 million tickets. Only one will win. You're told each individual ticket has a 0.000001 chance of winning, practically nothing. So for every ticket, it seems rational to say, this ticket will lose. You look at ticket 1, this will lose. Ticket 2, this will lose. Ticket 3, all the way to ticket 1 million, every single one will lose. But now you've formed 1 million rational beliefs, that each ticket will not win. Here's the problem. You also know that one of these beliefs must be false, because someone will win. This creates the paradox. It seems rational to believe of each ticket it will not win, but it is irrational to believe none of the tickets will win. Yet that's exactly what you end up believing when you believe each one won't win. So your set of beliefs, while individually rational, becomes collectively irrational. That's the lottery paradox. How can a collection of beliefs, each based on solid logic and evidence, become contradictory as a group? This paradox strikes at the heart of how humans, scientists, and even computers form expectations based on probability. It reveals the gap between what we believe about the world piecemeal and what happens when those pieces are assembled into a larger belief system. Let's apply this to real life. Imagine a doctor runs 100 diagnostic tests, each with a 99.9% accuracy rate. Each negative result makes them believe, confidently, that the patient is free of that condition. But what if the probability of a false negative over all 100 tests is high? Believing the patient has none of the conditions might be too strong, despite each belief being individually justified. Or consider national security. An intelligence analyst might say of 1,000 suspect locations, this one is not a threat, based on strong data. But to say that none of them are threats, that might be dangerously false. The lottery paradox shows us a flaw in the way we aggregate belief. Should we withhold belief about each ticket to preserve logical consistency, or should we accept small-scale contradictions as inevitable in a probabilistic world? Philosophers have taken different paths. Some suggest changing our rules about belief entirely. Instead of saying we believe something based on high probability, we might say we simply accept it for practical purposes, but not fully commit to its truth. Others argue we should adopt a threshold for belief. Believe only what has a probability above a certain point and doesn't conflict with the rest of our beliefs. That way, we're safe from paradox. but also slower to form conclusions. There's also the idea of non-monotonic logic, where beliefs can change or be retracted as new information comes in. In this model, belief is more fluid, adapting to the environment like a GPS rerouting through traffic. In AI, this is critical. Intelligent systems often operate with uncertain data. Should a robot believe that no obstacles exist on a path if each sensor says no obstacle with 99.9% certainty? The wrong aggregation can lead to errors, and in physical systems, those errors can be fatal. In human psychology, the paradox appears too. You believe your plane won't crash, your friend believes theirs won't. Everyone on board feels the same. And yet, you all know, some planes do crash. Each belief is reasonable, the group belief is shaky, and yet we live this contradiction every day. We cross the street believing we won't be hit. We drive cars, take medicine, eat food from strangers, believing in probabilities, not certainties. It's about living in a world of almosts, where belief is necessary but certainty is impossible, and contradictions inevitable. So next time you think, this won't happen, ask yourself, what if I said that 1,000,000 times? Would you still believe it? Would it still make sense? Or would the world slowly, surely prove you wrong? Russell's paradox. Imagine a catalogue that lists every catalogue that does not list itself. One day someone asks, should this catalogue list itself? If it does, it shouldn't. If it doesn't, it should. Now your brain crashes. In 1901, Bertrand Russell, one of the most influential logicians and philosophers of the 20th century, uncovered a terrifying flaw at the heart of mathematics. What he found wasn't just a riddle or a curiosity. It was a paradox so foundational, it nearly shattered the logic of set theory, mathematics, and reason itself. Until then, many believed that mathematics could be built from set theory, where everything could be categorized, grouped, and logically defined. But Russell discovered a contradiction in the most basic assumption of all, that any collection or set can be defined simply by stating a clear condition. He realized something horrifying. Logic can break itself. And it all starts with one innocent-sounding question. Can a set contain itself? Let's dive in. In set theory, you define a set by a property its members share. For example, the set of all books in a library, the set of all even numbers, the set of all chairs in a room. Now imagine the set of all sets that do not contain themselves. Let's call this set R. So, R equals the set of all sets that are not members of themselves. Simple, right? Now comes the twist. Is R a member of itself? Let's suppose R is a member of R. That means R is one of the sets that do not contain themselves. But we just said R does contain itself. That's a contradiction. So let's try the other option. Suppose R is not a member of R. That would mean R meets the condition of sets that do not contain themselves, which means it should be a member of R again. A contradiction. This is Russell's paradox. It's not a joke, it's a logic bomb. And when Russell discovered it, the entire mathematical world trembled, because this paradox appears not from complex theorems, but from the most basic assumption of set theory, that sets can be freely formed from any definable property. This one idea, so simple, led to a contradiction, and that contradiction meant mathematics could not trust its own foundation. Russell's discovery sent shockwaves through the world of logic and math. The prestigious German logician Gottlob Frege, who had spent decades developing a system to ground all of mathematics in logic, received Russell's letter outlining the paradox. His reaction was devastating. Your discovery of the contradiction has shaken the ground on which I meant to build arithmetic. Frege's life's work collapsed in a single sentence. And yet, paradoxically, this crisis sparked a revolution. To fix the problem, new systems of logic had to be created, ones that avoided the trap Russell found. One of the most influential was Zermelo-Fraenkel set theory, ZF. In this system, sets are built in layers or stages. A set can only be constructed from previously existing sets, not from sets that refer to themselves. This hierarchy prevents self-referencing loops like Russell's. In simple terms, no more catalogues that catalogue themselves. Another response came from Russell himself, in the form of type theory, a system that assigns different types or levels to sets so that a set can never contain itself, or even talk about itself. In modern computing, type theory is foundational. It governs how data is structured, how programming languages are designed, and how software avoids crashing into infinite self-references. And in philosophy, Russell's paradox has profound consequences. It challenges how we think about reference, language, and abstraction. Can a word describe itself? Can a system define its own limits? These questions now echo through disciplines like linguistics, semiotics, and the philosophy of mind. Even Gödel's incompleteness theorems, which shook the foundations of mathematics in the 1930s, used a similar trick, self-reference, to show that no consistent system of arithmetic can prove all truths about itself. And today, we still face Russell's ghost. In AI, recursive models that analyze their own output risk falling into similar paradoxes. In law, recursive legislation, rules about rules, can generate contradictions. Even in psychology, trying to fully know your own mind is a recursive loop. Can the eye truly see itself? So what's the takeaway? Russell's paradox teaches us that not all questions are valid, even if they sound valid. It shows that some loops must be broken, some definitions must be denied, not because we lack the intelligence to solve them, but because the structure itself is unstable. And in that sense, the paradox becomes a warning. Be careful what you try to define. Be cautious when your system begins to point at itself, because sometimes that mirror reflects nothing. So the next time you think about defining something, whether a system, an identity, or even yourself, pause and ask, am I building a solid foundation or a spiral with no bottom? Because once the question turns inward, it might never let you go. The two-envelope paradox. You're handed two sealed envelopes. One has twice as much money as the other. You choose one at random, but before opening it, you're told you can switch. Should you? Every time you calculate, switching seems better. But then? Shouldn't you just keep switching forever? The two-envelope paradox first emerged in formal philosophical literature in the late 20th century, but can be traced back further to earlier forms of decision-making paradoxes. It's often credited to Raymond Smullyan, a logician and puzzle maker who presented versions of the problem that left even advanced thinkers baffled. It became especially prominent in the fields of probability theory, mathematics, economics, and rational choice theory. At first glance, it seems like a clever little riddle, but when examined, it reveals deep contradictions about expected value, information theory, and our intuition about risk. Let's walk through the scenario carefully. You're told there are two envelopes. One contains an unknown amount of money, say X. The other contains either half that amount, X/2, or double 2X. You don't know which is which. You choose one envelope at random. You don't open it. Now, someone offers you the chance to switch. You begin to think. Let's say the envelope you picked contains $100, 0 cents. Then, there's a 50% chance the other envelope contains $50, 0 cents. There's a 50% chance it contains $200, 0 cents. So, the expected value of the other envelope is 0.5x $50, 0 cents, plus 0.5x $200, 0 cents, equals $25, 0 cents, plus $100, 0 cents. That's more than $100, 0 cents. So it makes sense to switch. Now you hold the new envelope. But wait, you can use the exact same logic again. If this has $100, 0 cents, the other envelope must be $50, 0 cents, or $200, 0 cents, so the expected value is $125, 0 cents again. I should switch. Now you're stuck in a loop. Endless switching. How can switching always be better, no matter which envelope you choose? That's the two-envelope paradox. At first glance, the logic seems airtight, but it leads to a contradiction, an infinite loop of preference. If every time you compute expected value switching is better, then rational behavior becomes irrational. You switch endlessly and never open an envelope. So where does the error lie? Let's dissect it. The flawed assumption. Fixed values versus random variables. The paradox plays a subtle trick with X, the unknown value. When you assume that the envelope contains $100, 0 cents, you're treating $100, 0 cents as a fixed value. But then you treat the other envelope as possibly being $50, 0 cents, or $200, 0 cents, implying that the envelope you picked could be either the larger or the smaller one. You're assigning equal probability, 50%, to both cases, without evidence. That's the first issue. In reality, If we don't know the distribution of how these envelopes were filled, then we can't fairly assign probabilities to the smaller amount via's larger amount. In other words, your assumptions about probability are arbitrary. The deeper issue: undefined prior distributions. Suppose there's no upper or lower bound on how much money could be in an envelope. Then the distribution of possible values is improper. It doesn't sum to 1. Mathematicians call this an improper prior, and it leads to paradoxes like this. To resolve it, we must define a probability distribution of how likely different amounts are to appear in envelope. Once we do, the paradox dissolves. For example, if we know the organizer randomly chooses $50.00, then fills one envelope with $50.00 and the other with $100.00, then, if you open the $100.00 envelope, switching loses you money. If you open the $50.00 envelope, switching gains you money. So without knowing the rule behind the envelopes, the expected value calculation is not valid. This is why the paradox is so dangerous. It gives you a false sense of precision in your decision. Psychological trap: the illusion of free information. Part of the paradox's appeal is that it feels like a free win. You've done some math. The numbers are real, the logic seems clean, so switching must help. But the paradox exploits your assumption that expected value always applies, even when key information is missing. This reflects real-world behavior. In gambling, finance, and AI decision-making, agents often overestimate expected gains based on faulty assumptions. And in human life, we often act like we're due for a win, or believe that switching, changing partners, careers, investments must improve things. The two-envelope paradox shows that sometimes change for the sake of change is just spinning in place. Resolutions and lessons. So how do we resolve it? Most philosophers and mathematicians agree. The paradox arises because you try to calculate expectations without a proper probability model. Without knowing how the envelopes were filled, the calculation is meaningless. Some also argue that the paradox illustrates the limits of naive decision theory. Expected value is a powerful tool, but only when its assumptions are valid. Others suggest avoiding the paradox entirely by simply opening your envelope. Once you know the number inside, the whole puzzle disappears. But in doing so, you learn the paradox's greatest truth. Uncertainty creates illusion. And sometimes, the math only looks like magic because you're counting invisible things. So the next time you're tempted to switch, whether in theory or in life, pause and ask, what do I actually know? What am I assuming? And am I switching for something better, or just chasing a number that was never real? The preface paradox. An author writes a book. Every chapter thoroughly researched, cross-checked, verified. But in the preface they humbly write, despite my best efforts, some errors may remain. So, which is it? Do they believe each chapter is true, or that at least one is false? The preface paradox was first articulated by philosopher David Makinson in 1965. It explores a dilemma that arises when we try to be rationally humble, acknowledging the possibility of being wrong, even when we believe all our claims are right. It's called the preface paradox, because many authors express this very tension in the opening of their books. They say, in effect, everything I've written here is true, but I may have made a mistake. It's not just modesty, it's rational behavior, and yet it creates a paradox. How can it be reasonable to believe every statement in a book while also reasonably believing that some statement in the book is probably false? The preface paradox challenges our concept of consistency in belief. It pushes us to confront the difference between individual certainty and collective doubt, a problem that stretches deep into epistemology, statistics, and human psychology. Let's walk through it carefully. Imagine you've written a non-fiction book. It contains 100 factual claims, each thoroughly supported by evidence, reason, and sources. For each claim, you've triple-checked everything so you believe each individual claim is true, but you also know authors make mistakes, typos happen, misquotes slip in, interpretations evolve. So you write in the preface, to the best of my knowledge, this book is accurate, but given the complexity of the subject, it's likely that at least one error remains. This sounds responsible, thoughtful, rational, but here comes the paradox. You're saying, I believe claim 1 is true, I believe claim 2 is true, and so on through claim 100, but then you also believe at least one of these claims is false. That's a contradiction. You're simultaneously believing all of these are true and not all of these are true. How can you hold both beliefs and still be rational? This is the preface paradox. It exposes a tension between two things we try to do: be confident in each of our beliefs, be humble about our ability to avoid error. These two virtues, certainty and humility, seem incompatible when lined up in logic. And yet, we all live like this. Doctors prescribe treatment plans they trust, but still admit uncertainty. Engineers sign off on blueprints, but include error margins. Authors write books they believe in while apologizing in advance for mistakes. This isn't hypocrisy, it's how rational minds navigate a complex world. So how do philosophers explain this contradiction? Option 1. Reject the set of beliefs. Some argue that if you believe each claim is true, you must believe the entire book is true, and therefore cannot rationally believe it contains an error. But this feels unrealistic. If each claim has a 99% chance of being correct, then statistically, across 100 claims, there's a strong chance at least one is wrong. So even if you're confident in every part, you know the whole may contain a flaw. This creates the paradox. You believe each, but doubt the sum. Option 2. Probabilistic belief. Others propose a probabilistic solution. They argue that belief isn't binary, it's about confidence levels. So instead of saying, I believe every claim is true, we should say, I believe claim 1 is 99.9% likely to be true. I believe claim 2 is 99.9% likely to be true, and so on. If you multiply those probabilities across all 100 claims, the probability that all are true drops significantly. So while your confidence in each claim is high, your confidence in the entire set being flawless is low. Therefore, your belief that some error may remain isn't contradictory, it's statistically informed humility. Option 3. The difference between belief and expectation. Another view is that belief in a single claim is epistemic, based on justification, but belief that some error exists is an expectation, based on background knowledge about human fallibility. So you're not saying I believe this specific claim is wrong, you're saying given my experience, I expect that one of these is probably flawed. Expectation doesn't counsel belief, it complements it with caution. This allows people to maintain belief in every detail while being skeptical about perfection. Real-world applications. The preface paradox plays out everywhere. In jury decisions, where jurors believe in individual facts of a case, yet still fear they might have missed something. In academic research, where authors carefully defend every statement, but still end their paper with, future work is needed. In AI systems, where models make predictions based on probabilities, not certainties, and are expected to be mostly right, but sometimes wrong. It's also deeply human. We walk through life believing in the choices we make, while carrying a soft, silent doubt that says, but I could be wrong. This paradox doesn't mean we're irrational, it means we're alive. So, what do? We live with the paradox. We write the book, and we write the preface. We trust our knowledge, and we question our perfection. We believe deeply and doubt honestly. And maybe, just maybe, that's what makes belief worth having at all. Not because it's flawless, but because we know it might not be. The twin paradox. Two twins. One stays on Earth, the other boards a spaceship and flies at nearly the speed of light. Years pass. When they reunite, one is older, the other barely aged. Did time itself play favourites? The twin paradox is one of the most iconic puzzles in modern physics. It doesn't come from ancient philosophers, but from the 20th century, born out of Albert Einstein's theory of special relativity. First formulated in 1905, Einstein's theory radically altered our understanding of time, space, and motion. It showed that time doesn't flow the same for everyone. It bends, stretches, and contracts depending on speed and gravity. Shortly after, physicists imagined the twin scenario as a way to test this wild idea. What happens when one person stays on Earth and another travels near light speed? The answer seems to violate everything we know about clocks, aging, and common sense, and yet, it's real. Let's break it down. You have two identical twins, Alice and Ben. Alice stays on Earth. Ben boards a spaceship that travels at 99.999% the speed of light. According to Einstein, time for a moving object slows down relative to a stationary observer. This is called time dilation. So, as Ben zooms through the cosmos, time moves slower for him. at least from Alice's perspective. Imagine Ben travels for 10 years by his own clock, then turns around and comes back. When he returns, he finds that decades have passed on Earth. Alice has aged 40, 50, or even 100 years, depending on how far he went and how fast. But here's the twist, the paradox. From Ben's perspective, wasn't her time have slowed down? Why does he come back younger? The puzzle seems symmetrical. Each twin should see the other as moving. So why is there a clear aging difference? That's the core of the twin paradox. So what's really happening? The resolution lies in asymmetry. The twins may seem to have equal roles, but their experiences are not the same. Ben accelerates to near light speed, turns around, decelerates, and returns. Alice stays in an inertial frame, no acceleration, no movement. In special relativity, the rules for moving frames are different from those for accelerating frames. Ben's journey involves switching reference frames when he turns back, introducing an asymmetry that breaks the illusion of equality. So the result isn't a contradiction, it's a consequence of relativity. And we've tested it. In 1971, scientists put atomic clocks on jet planes and flew them around the Earth. When compared to identical clocks on the ground, the flying clocks ticked slower, just as predicted. GPS satellites also account for this. Their clocks are adjusted to compensate for both the speed they travel and the weaker gravity they experience in orbit. Without those adjustments, your phone's GPS would be off by miles. So the twin paradox is more than a thought experiment. It's a window into how the universe really works. But the implications are unsettling. It means time is not universal. Two people can experience different durations of time between the same events, and both are right. It means your concept of now might not be the same as someone else's, and it opens the door to mind-bending questions. Could astronauts live longer by spending more time in space? Could we time travel into the future by approaching the speed of light? What happens to consciousness when time slows down? Does the brain slow too? Even deeper, the paradox makes us question the nature of identity over time. If Ben returns decades younger, is he still Alice's twin in every meaningful way? Or has their shared reality fractured? And then there is the emotional weight. Ben returns, his sister has aged. Friends are gone, the world has changed. To him, just a few years passed. But he's now a relic of the past, dropped into a future he didn't live through. The twin paradox is a story not just of physics, but of separation, perspective, and irreversibility. Because once time splits, you can never walk the same road again. It also has implications for science fiction. If you've ever watched Interstellar, you've seen the effects of time dilation play out emotionally, not just mathematically. The twin paradox inspired countless fictional narratives where time is the enemy not because it moves too fast, but because it moves differently. Even philosophically, it makes us ask, what is aging? Is it simply the passing of years? Or is it the accumulation of experience? If Ben lived only 10 years of experience, is he emotionally younger, mentally fresher than Alice? Or is he simply out of sync with everything he once knew? And as technology advances, and if space travel becomes real, at relativistic speeds, this paradox may not remain philosophical. We may one day face the ethical and personal consequences of sending loved ones far into the stars, knowing they'll return unchanged while we fade into memory. So the twin paradox isn't just a scientific curiosity. It's a mirror held up to time itself, and in its reflection we see the strangeness of a universe that doesn't treat time as a river but as a landscape, a place where paths stretch longer or shorter depending on the way you walk them, where clocks tick differently for different travelers, and where love, loss and memory all stretch, not across miles, but across moments lived differently. The problem of evil. If God is all-powerful, all-knowing and all-good, why is there evil in the world? Why do children suffer, wars rage, and innocent lives end in pain? Is evil a flaw in the world, or in our understanding of divinity? The problem of evil is one of the oldest and most powerful arguments against the existence of a traditional, omnipotent, omniscient, and omnibenevolent God. It dates back to Epicurus, a Greek philosopher in the 3rd century BCE. He posed the challenge simply and devastatingly. Is God willing to prevent evil, but not able? Then he is not omnipotent. Is he able but not willing? Then he is malevolent. Is he both able and willing? then whence cometh evil? This elegant trilemma formed the core of the argument from evil. Over centuries, philosophers, theologians and skeptics wrestled with it, from St. Augustine to Leibniz, from David Hume to J.L. Mackie. Despite thousands of years of theology and reflection, the paradox remains, staring at us not just from the pages of philosophy, but from the daily headlines and personal heartbreaks we all witness. Let's walk through the puzzle more formally. The traditional conception of God includes three essential attributes. Omnipotence. God can do anything. Omnipovalence. God is perfectly good and wants what is best. Now, add a fourth, observable fact: evil exists. By evil, we don't just mean malice. We mean suffering, injustice, natural disasters, needless deaths, torture and tragedy. Both moral evil, caused by humans, and natural evil, earthquakes, disease, famine. If God is all-powerful, he can stop evil. If he is all-knowing, he knows how and when it happens. If he is all-good, he wants to stop it. So why doesn't he? That's the problem of evil. It doesn't deny the existence of God outright, but it challenges the compatibility of God's traits with the world we observe. Let's explore some responses. 1. The free will defense. One of the most common responses is the free will defense, famously articulated by St. Augustine and developed by modern thinkers like Alvin Plantinga. It argues God gave humans free will. Free will is valuable. It allows for real love, real choice, and real meaning. But with that freedom comes the potential for evil. According to this view, moral evil, like murder or cruelty, is not God's doing, but ours. But what about natural evil? Earthquakes, cancer, floods, things no one chooses? Some argue these are necessary to create a world of soul building, a world where we grow, develop compassion, face challenges, and overcome suffering. But others call this a rationalization for an unfair system. 2. The greater good argument. Another approach is that God allows evil to exist because it leads to greater goods. Just as a parent may allow a child to feel pain from a vaccine, God may permit suffering that results in long-term benefit, perhaps in ways we can't see. This defense appeals to mystery, the idea that our knowledge is limited and we cannot expect to grasp divine reasoning. But critics point out, if God is all-powerful, couldn't he achieve good without evil? Isn't omnipotence the power to do good without trade-offs? If we need evil to grow, doesn't that suggest a limit in God's design? 3. The logical problem versus the evidential problem. Some distinguish between two versions of the problem. The logical problem of evil argues that God's existence is logically incompatible with evil. The evidential problem concedes that it's logically possible, but highly unlikely. Think of it like this. You hear of a man who claims to be a firefighter, on duty 24/7, stationed at the only firehouse in town. Then a house burns down while he's sitting outside. You could say, well, maybe he had a good reason not to act. But the more fires you hear about, the more victims you see, the harder it becomes to believe in his claim. That's how evil works as evidence, builds a case, not of contradiction, but of disbelief. 4. The rebuttal, redefining God. Others tackle the problem by redefining the divine. Maybe God isn't all-powerful, just more powerful than us. Maybe God is all-loving, but love means allowing pain. Maybe God is not a being at all, but a process, a force, an evolving consciousness. These views shift away from traditional theism toward process theism, pantheism, or mysticism. But at that point, critics argue, you're no longer solving the paradox. You're escaping it by changing the rules. So, where does that leave us? The problem of evil remains one of the strongest arguments against the existence of a traditional, all-powerful, all-loving God. But it is also one of the most emotionally complex. Because it's not just about logic. It's about holding a dying child. It's about watching war destroy families. It's about the hollow ache that asks, why? And sometimes, no answer feels good enough. And yet, people continue to believe. Not because the paradox is resolved, but because faith, for many, isn't about avoiding tension. It's about enduring it. Some believe in God because of evil, because they long for justice, for redemption, for healing beyond this world. Others reject God, not out of hatred, but out of heartbreak, because they expected more. The problem of evil doesn't break belief, it defines its depth. Because to believe in a good God in a cruel world is to live inside the paradox. and still choose hope. Newcomb's paradox. You walk into a room. On the table are two boxes. One is transparent and holds $1,000, 0 cents. The other is sealed. You're told it contains either $1 million, 0 cents, or nothing. But there's a twist. A powerful predictor already guessed what you would do. Do you take both boxes, or just the sealed one? Newcomb's paradox was first introduced by physicist William Newcomb in the 1960s and later popularized by philosopher Robert Nozick. What seemed like a quirky decision game quickly became one of the most debated puzzles in philosophy, game theory, decision theory, and even AI research. It pits free will against prediction, rational choice against causality, and asks one haunting question. Can your future choice already be known? And if so, does it still count as a choice? Unlike many paradoxes that depend on wordplay or unlikely scenarios, Newcomb's paradox forces us to confront the limits of rational thinking in real-time decision-making. Here's the setup. You're faced with two boxes. Box A always contains $1,000, 0 cents. Box B contains either $1 million, 0 cents, or nothing. You're told the following. A highly advanced predictor, one with near-perfect accuracy, has already made a prediction about what you will do. If the predictor predicted that you would take only box B, it placed $1 million, 0 cents inside it. If the predictor predicted that you would take both boxes, it left box B empty. Your choice is simple. Do you take both boxes, A and B, or do you take only box B? Now your reasoning begins. If you take both boxes, you'll get $1,000, 0 cents, for sure, plus maybe $1 million, 0 cents, if the predictor got it wrong. So potentially, $1,000, 0 cents, or $1,000, 0 cents. If you take only box B, then you might get $1 million, 0 cents, or nothing, if the predictor anticipated wrongly. At first glance, taking both seems like a dominant strategy. No matter what's in box B, you get more by taking both. But remember, the predictor is almost never wrong. So if it predicted you'd take both, box B is empty. If it predicted you take only box B is full. Now the paradox takes shape, the two sides of the argument. One boxer say, I should take only box B. The predictor is nearly always right. If I take only box B, I'll probably get the million. If I take both, the predictor would have seen that, and I'll only get $1,000, 0 cents. This view emphasizes correlation. Your choice correlates with what's already in the box. Two boxes say, the money is already there, or not. My action now can't change the past. Taking both boxes always gives me more money, regardless of what's inside box B. This view emphasizes causality. Your current action cannot affect a past decision. So, who's right? The conflict between decision theories. Newcomb's paradox creates a war between two major decision theories. One, causal decision theory, CDT. Choose the action that causally brings the best result. My choice now doesn't change what's already in box B, so I'll take both, too. Evidential decision theory, EDT. Choose the action that gives the best evidence for a good outcome. Taking only box B suggests that the predictor saw this and rewarded me with $1 million, 0 cents. So I'll take only box B. Each side is internally consistent. CDT says, be rational, maximize outcomes, ignore superstition. EDT says, consider what your actions mean, not just what they cause. And so the paradox becomes not just a thought experiment, but a philosophical battleground. Real-world applications. Why does this matter? Because in the age of artificial intelligence, predictive analytics, and social engineering, Newcomb's paradox isn't theoretical anymore. If an AI predicts your behavior and tailors your options accordingly, does your decision still feel free? If companies adjust prices based on how likely you are to buy, are you truly choosing? If a predictive policing system forecasts where crime will occur, and your presence there confirms it, who shaped whose future? Even human psychology plays into it. We often act in ways that match expectations of others, teachers, parents, partners. If we believe someone expects greatness from us, we rise to it. If we believe they expect failure, we often fall. Are we freely choosing, or playing out a loop of belief and fulfillment? Newcomb's paradox forces us to confront free will as more than a gut feeling. The deeper question, Ultimately, this paradox raises the question, what is a choice? If your decision is predicted with 99.99% accuracy and you act accordingly, are you free? Or are you just the endpoint of an equation, a line in someone else's code? Some argue that free will and prediction can coexist, as long as the prediction isn't causally influencing the choice. Others argue that perfect prediction implies determinism. If you can be predicted with certainty, then you were never really choosing. And still others say, the paradox only feels hard because we imagine time as linear, but maybe, like in quantum mechanics or relativity, causality is more flexible than we think. So, what would you do? You walk into the room, 2 boxes. A predictor with near-perfect accuracy has already made its call. If you take 1 box, you'll likely walk out $1 million 0 cents richer. If you take 2, you'll definitely get $1,000 0 cents, and probably nothing more. But you can't shake the feeling. If I take both, I'm outsmarting the system. If I take 1, I'm surrendering to fate. In that moment, Newcomb's paradox isn't about logic, it's about trust. Do you trust your freedom or someone else's foresight? Moore's paradox. Imagine saying this out loud. It's raining, but I don't believe that it's raining. You haven't lied. The weather matches your words, yet something feels off. Absurd, even. You've just stepped into the strange world of Moore's paradox. Named after the British philosopher G.G. Moore, this paradox was first introduced in the early 20th century as part of his exploration of common sense, knowledge, and belief. Moore was fascinated by the seemingly simple but deeply complex objet statements we make every day. He wanted to show that some philosophical positions, especially skeptical ones, violate what he called the common sense view of the world. But in making his point, he stumbled upon something truly strange. It is raining, but I don't believe it is raining. A sentence like this can be logically consistent. It doesn't contradict itself the way it is raining and it is not raining would, but it's also deeply irrational to say, so much so that anyone who says it immediately seems confused or unreliable. Why is that? What Moore revealed is that sometimes logic and language crash into something deeper, the way our minds represent belief, and how belief itself connects with truth. Let's explore why Moore's paradox is so unsettling. The classic Moorean statement is, it's P, but I don't believe that P. Examples. It's sunny, but I don't believe it's sunny. The stock market crashed, but I don't believe it did. She loves me, but I don't believe she does. Each of these statements could technically be true. The facts in the first half might be real, and the speaker might honestly not believe them, and yet, saying them out loud feels ridiculous. That's the paradox. So, what's going on? At its core, Moore's paradox isn't about contradiction in logic, it's about contradiction in mental states and speech acts. To say it's raining is to assert something as true, but to then say, I don't believe it's raining, undermines the credibility of your own assertion. You're expressing certainty and doubt in the same breath. The paradox in action. Imagine your friend tells you the test is tomorrow, but I don't believe the test is tomorrow. What would you think? Even if they're correct, you'd question their mental state. How can they assert something as true while denying belief in it? This tension isn't a matter of fact. It's a conflict between saying something and believing it. 2 versions of the paradox. Moore's sentence, out loud. It's raining, but I don't believe it's raining. Moore's belief. Believing, it's raining, but I don't believe it's raining. The second is even more bizarre. How can you believe something while simultaneously believing that you don't believe it? It suggests an incoherent mind, one that holds 2 incompatible attitudes at once. Why this matters? At first glance, Moore's paradox seems trivial, a linguistic slip, a curiosity, but it cuts deep. It exposes the gap between what we say, what we believe, what we know about our own minds. And in doing so, it challenges foundational assumptions in epistemology, philosophy of mind, and linguistics. Applications in philosophy. 1. Self-acknowledge. Moore's paradox suggests we should always know what we believe, but in real life we often don't. We might say one thing, act another way, and only later realize what we truly believe. This paradox calls into question the assumption that our beliefs are always transparent to ourselves. 2. Belief reports and language. If someone says, it's raining, but I don't believe it, What should we infer? Are they misinformed? Being sarcastic? Lying? Moore's paradox reveals that assertion and belief are tightly linked, and breaking that link produces not a contradiction, but a kind of cognitive dissonance. 3. Epistemic norms. Some philosophers argue that asserting something requires that you believe it. To say P without believing P is not just weird, it's epistemically inappropriate. Moore's paradox demonstrates what happens when we try to assert something we don't endorse internally. The result is confusion, mistrust, and breakdown in communication. The AI analogy. In the world of artificial intelligence, Moore's paradox has found a new home. Imagine programming an AI to say, "This file is dangerous, but I don't believe it is." Would you trust that machine? Probably not. Moore's paradox reveals that consistency between assertion and belief is a foundational trust factor, not just in humans, but in machines too. When that consistency breaks, so does our ability to rely on what's being said. The psychological angle. Moore's paradox can also occur in our private lives. You might know your partner loves you, but you don't believe it. You might know your talent is real, but feel like an imposter. In these cases, Moore's paradox is emotional, not logical. It points to the fracture between rational knowledge and felt belief. So perhaps the paradox is not absurd at all, but a mirror for the strange ways we disown our truths. Living the paradox. We've all felt it. You say, "I'm fine," but you don't believe it. You tell a friend, "Everything will work out," but you're unsure yourself. Moore's paradox lives in these everyday contradictions. Not lies, not hypocrisy, just the complexity of being human. We can say things we don't yet believe things we can't yet say, and sometimes we live between those two spaces, longing for one to catch up with the other. Final thought. Moore's paradox doesn't break the world, it holds up a strange little sign that says, "You're not always as coherent as you think." But maybe that's okay. Maybe being human means being able to assert things we haven't caught up to yet. Maybe belief isn't a single switch, but a spectrum we walk along, unsure of where we stand until the rain soaks us through. The Gettier problem. What if you had a belief that was true, justified, and still not knowledge? Imagine finding the truth by sheer accident. Is that wisdom, or just dumb luck in disguise? For thousands of years, philosophers defined knowledge as a simple equation: justified true belief. In other words, you know something if you believe it, it is true, and you have good reason or justification for believing it. This definition was considered solid until 1963, when philosopher Edmund Gettier published a short paper, barely 3 pages long, that shook the entire world of epistemology. In those 3 pages, Gettier showed that justified true belief might not be enough. Sometimes you can have all 3 elements and still only be accidentally correct. It became known as the Gettier problem, a puzzle that fractured our understanding of knowledge itself. Let's break it down with a classic example. Suppose Smith and Jones are applying for the same job. Smith has strong evidence to believe that Jones will get the job. Maybe he heard it from the boss. Smith also believes that Jones has 10 coins in his pocket. He saw Jones count them. Smith then forms the belief: the person who will get the job has 10 coins in their pocket. This belief is justified. It is based on valid evidence. It also turns out to be true. But here's the twist. Jones doesn't get the job, Smith does. And by complete coincidence, Smith also has 10 coins in his own pocket. But he didn't know that. So the statement, "the person who will get the job has 10 coins in their pocket," is true. Smith believed it, and he had justification. But clearly, Smith didn't really know it. His conclusion was right, but for the wrong reasons. This is a Gettier case. Why it's a problem. Gettier showed that even when all 3 conditions are met, knowledge can still be missing. Imagine shooting an arrow blindfolded and hitting the bullseye. You had no aim, no skill, but the wind carried it perfectly. The arrow hit the target, yes, but did you do it? Knowledge, it turns out, is more than just being correct with justification. It requires connection between the truth and why you believe it. But what is that missing link? Attempts to solve the Gettier problem. Since 1963, philosophers have tried dozens of refinements to fix the definition of knowledge. Some of the most notable include 1. O false lemmas. This view adds a 4th condition: your belief must not be based on any false assumptions. But this leads to complex debates. What counts as a false lemma? How deep do we trace them? 2. Causal theory of knowledge. This theory, proposed by Alvin Goldman, says knowledge is a belief that is causally connected to the truth. In Smith's case, his belief that the person with 10 coins would get the job wasn't causally connected to his own job offer. So it fails. But how do we measure causal chains for abstract truths like math or ethics? 3. Relayabilism. Instead of focusing on justification, some suggest that knowledge comes from reliable belief-forming processes. If your cognitive tools usually get things right, then the occasional fluke might still count. Still, this raises more questions. What defines a reliable process? How do we assess them across different contexts? 4. Virtue epistemology. This theory argues that knowledge is like a skill. It arises from intellectual virtue. Not by luck, but through competence. But defining intellectual virtue opens up an entirely new philosophical front, real-world implications. The Gettier problem isn't just academic. In the age of information overload, it challenges how we trust news sources, interpret statistics, understand our own memories, train artificial intelligence. For example, suppose an AI model predicts a stock will crash because of market analysis. But in reality, a random scandal caused the crash. The AI was right, but for the wrong reason. Does it know the market? When we say we know something in everyday life, are we just lucky thinkers? Is modern belief just a series of well-dressed guesses? The emotional side. The Gettier problem also pokes at human confidence. How often have you felt absolutely sure about something, only to later discover your reasoning was flawed, even if you were correct? It makes us question how much of our certainty is illusion. Is being right always enough? Are we walking through life with beliefs stitched together by threads of chance? There is something deeply humbling in realizing that justified true belief is not the summit. Knowledge is not just about arriving at truth. It's about the path you took to get there. The Gettier problem doesn't destroy knowledge, it refines it. It reminds us that truth isn't enough, that belief alone won't cut it, that even when the stars align, they may have done so for reasons you never understood. In a world that rewards confidence and clarity, Gettier whispers a soft warning. You might be right, but do you really know why? And sometimes, that question is more important than the answer. The paradox of inquiry. How can you search for something when you don't know what it is? And if you already know it, why search at all? You're trapped, either in ignorance or redundancy. Welcome to Meno's paradox, where the act of learning becomes a mystery in itself. This paradox comes from Plato's dialogue Meno, where Socrates and Meno discuss the nature of virtue, what it is, and whether it can be taught. In the process, Meno poses a question that unravels the very process of learning. How will you inquire into something when you are wholly ignorant of what it is? If you know what you're looking for, inquiry seems unnecessary. But if you don't know what you're looking for, how would you even recognize it when you found it? It's a classic epistemological dilemma. The learner appears doomed either to never begin or to never need the search. Let's break down the paradox in its two main horns. Horn 1. If you know it, you don't need to inquire. If you already know what virtue is, there's no need to search. It's already in your mind. This side says, why investigate what you already know? Horn 2. If you don't know it, inquiry is impossible. If you have no idea what virtue is or what it looks like, how will you even recognize the answer if it shows up? This side says, you won't know it when you see it. Together, these two horns trap us. Know it equals no need to inquire. Don't know it equals can't inquire. Thus, learning seems impossible. Socrates' response, theory of recollection. Socrates doesn't deny the paradox. Instead, he sidesteps it with a bold metaphysical claim. The soul is immortal and has already seen everything, so learning is just remembering what you already knew. According to this theory of recollection, inquiry works because the soul recognizes truth when it encounters it. This shifts the nature of learning, from acquiring something new to awakening something forgotten. Socrates demonstrates this by guiding a slave boy through a geometry problem. Though the boy has never studied math, he's able to rediscover truths through questioning. Is this proof of reincarnated knowledge, or just a clever example of guided inquiry? Modern interpretations. Today, few take the theory of recollection literally, but Meno's paradox still haunts modern philosophy, especially in 1. Artificial intelligence. Can a machine truly learn if it starts with zero knowledge? Or must it be primed to recognize certain patterns? Even advanced language models are trained on existing data. They don't begin in true ignorance, and their ability to recognize information depends on predefined parameters. 2. Education and epistemology. The paradox challenges how teachers and students engage. How does a student begin learning something they can't define? How do we teach abstract concepts, like justice, love, or art, without first knowing their essence? Some argue that learning is gradual refinement, not a binary switch. We start with vague ideas and refine them through experience and reasoning, but even then, how do we begin the process without some spark? 3. Scientific discovery. Every major breakthrough starts with a question, but where do those questions come from? If scientists didn't already have some idea of what to look for, how could they design experiments? And, if they already knew the answer, would the inquiry be genuine? This tension between ignorance and insight is the engine of discovery, and the very heart of Menno's paradox. Possible solutions to the paradox. A. Partial knowledge. Perhaps we're never totally ignorant or totally informed. We begin inquiry with hunches, intuitions, analogies, and incomplete information. We refine these over time into clarity. This idea supports modern learning theories. We bootstrap our way toward understanding. B. Recognition without prior knowledge. Maybe we don't need to fully know what we're looking for. We simply need to recognize coherence when we see it, much like a jury might recognize a convincing argument when presented with evidence, even if they didn't know what the truth looked like in advance. C. Inquiry as hypothesis-driven. Scientific method shows that learning often begins with tentative hypotheses. We test, reject, or refine these hypotheses not because we know the answer, but because we're exploring possibilities. The value isn't in already knowing the truth, it's in having a framework to test the unknown. The existential layer. At its deepest level, Menno's paradox is a metaphor for the human condition. We seek meaning, yet we don't always know what it looks like. We want love, truth, fulfillment, but can't define them precisely, and still we search. We ask, despite not knowing the shape of the answer. We recognize truths by how they resonate, not just by how they align with prior beliefs. This makes Menno's paradox less of a dead end, and more of a reflection of the mystery of learning. Menno's paradox isn't meant to discourage learning. It's meant to show that learning is magical. A leap from the unknown to the known, a bridge we build as we walk across it. It reminds us that every question begins in darkness, but carries the possibility of light. And maybe that's what makes the search worthwhile, not knowing what we're looking for, but searching anyway. The Epimenides paradox. A man from Crete stands up and says, "All Cretans are liars." But wait. If he's telling the truth, then he must be lying, and if he's lying, then maybe he's telling the truth. Welcome to the Epimenides paradox, a looping labyrinth of logic where truth devours itself. This paradox dates back to the 6th century BCE and is named after Epimenides of Knossos, a semi-legendary philosopher and poet from Crete. Epimenides once wrote, "The Cretans, always liars, evil beasts, lazy gluttons." Originally meant as a rhetorical critique of his own people, the statement evolved, especially the part about liars, into a logical knot. If a Cretan says that all Cretans lie, should we believe him? If he's telling the truth, then he's a liar, so he's not telling the truth. But if he's lying, then not all Cretans lie, which might make his statement true, and so the snake begins to eat its tail. The Epimenides paradox is the ancient ancestor of the more famous liar paradox, which we explored earlier. But its historical framing, where the speaker belongs to the group he condemns, adds a new layer of complexity. Let's zoom in on the key phrase, "all Cretans are liars." Let's suppose Epimenides is a Cretan. He is. Now consider, if his statement is true, then he is a liar. If he is a liar, then his statement must be false. But if the statement is false, then not all Cretans are liars. Which might mean Epimenides is telling the truth. And around we go. This is a self-referential paradox, one of the earliest in recorded history. It occurs when a statement refers to a set that includes itself in a way that undermines its own content. It is like trying to define a rule that applies to itself, like a commandment that says, "Ignore this commandment." What's really going on? The trouble lies in unqualified universal statements and self-reference. Epimenides makes a claim about all members of a group that includes himself. This creates a semantic loop. The meaning of the sentence relies on the truth of the sentence, which in turn undoes that very truth. The logic implodes not because of a factual contradiction, but because of a referential collapse, a sentence turning inward like a mirror reflecting itself. Impacts on logic and mathematics. The Epimenides paradox isn't just a quirky historical note, it inspired some of the most foundational developments in logic. 1. The liar paradox. The direct descendant of Epimenides' statement is the liar paradox. This sentence is false. This led to significant challenges in logic, truth theory, and set theory. 2. Gödel's incompleteness theorems. Kurt Gödel in the 20th century encoded similar self-referential paradoxes into formal mathematics. He showed that any consistent system of arithmetic will contain statements that are true but unprovable. His proof hinges on the idea that a statement can say something like, "This statement is not provable." Sound familiar? The ghost of Epimenides lingers. 3. Computing and the halting problem. Alan Turing's work on undecidability, especially the halting problem, relies on the same logic. Can a program analyze itself and determine if it will run forever? The answer, no. Self-referentialism introduces fundamental limits on what can be known or solved algorithmically. Philosophical ramifications. Beyond logic and math, the Epimenides paradox haunts. Epistemology. How do we define truth when truth statements can self-destruct? Ethics. Can we trust a moral system that critiques itself? Theology. What happens when sacred texts declare their own unreliability or authority? In each case, self-referential instability becomes the fissure through which certainty leaks. The human side of the paradox. We've all lived Epimenides moments. A politician says, "Don't trust politicians." A sign reads, "Ignore all signs." A friend says, "Everything I say is a lie." These aren't just jokes. They are epistemic black holes, moments where language folds in on itself. They remind us that our tools for describing the world, words, logic, assertions, are fragile and sometimes unstable, and yet we keep using them. Can it be resolved? Several attempts have been made to sidestep or classify the paradox. A. Differentiate types of truth. Some logicians distinguish between object-level and meta-level language. The paradox only arises when a sentence talks about its own truth within the same level. By keeping truth statements at a higher meta-level, you avoid the loop. B. Reject bivalence. In classical logic, every proposition is either true or false. But what if some statements are undefined or neither? This approach suggests that paradoxical statements like Epimenides are not false but not fully meaningful either. C. Paraconsistent logics. These are non-classical logics where contradictions can exist without collapsing the system. Under such a logic, you could accept that the statement is both true and false without triggering logical apocalypse. Final thought. The Epimenides paradox is more than a clever riddle. It's a gateway to the fragility of logic itself. It reveals that even our most basic tools for understanding truth can turn against us. It reminds us that not all puzzles have tidy answers, and perhaps most importantly, it teaches us humility, that truth may sometimes rest on the edge of a blade sharpened by its own contradictions. In that sense, the voice from Crete still echoes, not as a liar or a prophet, but as a mirror reflecting the mind trying to know itself. The Grelling-Nelson paradox. What do you call an adjective that describes itself? Short is a short word. Polysyllabic has many syllables. That's fine. But now ask, does the word heterological describe itself? And you've just stepped into a paradox so sharp it can split language in half. The Grelling-Nelson paradox was formulated in 1908 by German logicians Kurt Grelling and Leonard Nelson. It's a semantic paradox, one that arises not from statements about the world, but from the structure of language itself. The paradox centers around how adjectives describe or fail to describe themselves. It's deceptively simple, yet it leads directly to logical breakdowns akin to Russell's paradox in set theory. Let's begin with definitions. A word is autological if it describes itself. Examples. Short is short. English is an English word. Unhyphenated is unhyphenated. A word is heterological if it does not describe itself. Examples. Long is not a long word. French is not a French word. Polysyllabic is not polysyllabic, debatable. Here's the trap. What about the word heterological itself? Let's walk it through. Option 1. Heterological is heterological. That means it does not describe itself. But if it does not describe itself, and it's supposed to, then it is so this seems to work. Until you look again. Wait, if it is heterological, then it doesn't describe itself, which means it does describe itself as not describing itself, which means it does describe itself? Option 2, heterological is not heterological, then it must describe itself. But if it describes itself, then it means that heterological words do describe themselves, which they shouldn't. Either way, you fall into contradiction. If heterological is heterological, then it's not. If it's not, then it is. It's a self-referential trap, a snake swallowing its own semantic tail. The deeper implications. This paradox does for language what Russell's paradox did for sets. It reveals that some classification systems collapse when applied to themselves. Russell's paradox asks, does the set of all sets that do not contain themselves contain itself? Grelling-Nelson asks, does the adjective describing all adjectives that don't describe themselves describe itself? Both paradoxes show that self-references is a powerful but dangerous force in logic. They reveal that natural language, so flexible and intuitive, is also inherently unstable when pushed to extremes, impact on logic and semantics. The Grelling-Nelson paradox influenced major developments in 1. Formal semantics. It pushed linguists and logicians to develop formal languages that limit self-references or build in safeguards to handle it. 2. Type theory. Just as Russell resolved his paradox by proposing that sets can't contain themselves, logicians developed type theory to restrict what kinds of statements could refer to what. In type theory, you can't have a word refer to its own category unless specific rules allow it. 3. Philosophy of language. Philosophers began to distinguish between the use of a word and its mention. When we talk about the word short, are we using it to describe something short? Or are we just talking about the word itself? This distinction is subtle but crucial in avoiding paradoxes. The human side. This paradox isn't just abstract logic. It taps into the way we talk, write, and even think about thinking. Consider a modest person who brags about being modest. A sign that reads, "Ignore this sign." A book titled The Book of Books that don't list themselves, but lists itself. These situations feel awkward or humorous, but they're reflections of the Grelling-Nelson paradox in action. They make us realize how often we stand on slippery linguistic ground, using language that folds in on itself. Can it be resolved? A. Reject self-reference. One solution is to ban or regulate self-referential language. We can say, an adjective may not describe itself unless explicitly defined to do so. This works in formal logic, but it's unnatural in everyday speech. B. Contextual levels. Another fix involves meta-language. Statements about language are made in a different context or language level than the statements they describe. This helps us distinguish between talking about and talking within. See free-valued logic. Instead of true/false, some logicians propose a third value, undefined or paradoxical. Under this, heterological is heterological, has no truth value. It sits outside binary logic. This may sound like giving up, but it can be more accurate. After all, not every question has a yes or no answer. Some questions are flawed by design. Final thought. The Grelling-Nelson paradox is like a mirror maze made of words. At first, it's just a game. Classify adjectives. Then, suddenly, you're trapped in a hall of reflections, where a single word becomes both the key and the lock. It shows us that even the simplest questions can collapse into complexity when they turn inward. And it reminds us that language, our proudest tool for understanding the universe, sometimes folds in on itself and disappears. In that vanishing act lies a secret. There are limits to what can be said clearly, and in those limits, we find the boundary between logic and poetry. The paradox of the tortoise and Achilles. What if logic itself refused to obey logic? Imagine a tortoise outwitting the swift Achilles, not with speed, but with reason. Imagine a chain of arguments that can never quite reach their conclusion. Welcome to the paradox where rationality runs in circles. This paradox was introduced in 1895 by Lewis Carroll, the pen name of Charles Lutwidge Dodgson. better known for Alice's Adventures in Wonderland. But Carroll wasn't just a children's author. He was a mathematician, logician, and philosopher. His paradox appeared in a short dialogue titled What the Tortoise Said to Achilles, published in the philosophical journal Mind. It's a twist on Zeno's paradoxes, but this time the battlefield isn't motion, it's reason itself. Let's set the stage. Achilles, the logical, swift-thinking hero, meets a tortoise who challenges him to a simple argument. The tortoise presents two premises and a conclusion. A. Things that are equal to the same thing are equal to each other. B. The two sides of this triangle are both equal to a third side, therefore, Z. The two sides are equal to each other. Simple, right? Achilles agrees. Yes, that follows. But the tortoise says, hold on, you accept A and B, but do you accept that A and B together implies Z? Let's call that extra step C. If A and B are true, then Z must be true. Achilles, confused but polite, agrees, of course. But the tortoise is clever. Well then, to accept Z, you must also accept C. And that, A, B and C, implies Z. Let's call that step D. Now to truly accept Z, you must accept D, but to do that, you must accept E, that A, B, C and D imply Z. And so on. The chain never ends. No matter how many premises Achilles adds, the tortoise demands one more to link the previous ones to the conclusion. Conclusion? Logic needs another rule to justify each rule, which itself needs another rule. Thus, no conclusion can ever be fully accepted, because the very process of acceptance keeps moving the goalposts. What it really shows. This paradox isn't just playful rhetoric, it strikes at the foundation of deductive logic. In formal logic, an argument like premise 1, premise 2, therefore conclusion, is valid because we agree that certain forms of inference are valid. But Carroll asks, why do we accept the inference rules themselves? Do they need to be stated as premises? And if so, don't those rules need rules to validate them? It's like standing on a ladder that's built of smaller and smaller ladders. There's no first rung. Logical implications. 1. Rules versus meta-rules. The paradox distinguishes between propositions, A, B, etc., and the rules that govern how we move from premises to conclusions. Carroll shows that these inference rules can't just be added as more premises. That doesn't solve the problem. It extends it. You need a separate framework that governs all inference. 2. Proof versus acceptance. There's a difference between having a logically valid argument and someone accepting the conclusion. The tortoise accepts A and B, but won't move to Z unless the logical leap is explicitly spelled out. Again and again, this reflects real-world disputes. People often agree on facts but refuse the implications. Reason alone doesn't always compel belief. 3. Foundational limits. Carroll's paradox echoes what Gödel would later prove in mathematics. No consistent formal system can prove all truths about itself. There are always gaps, steps that cannot be filled within the system. You must step outside the system to validate it. Carroll's tortoise exposes this gap in logical reasoning itself, applications beyond philosophy, education. Teachers know that students often accept facts but don't internalize the logic that connects them. Law. Judges often spell out premises, but lawyers debate whether those premises actually justify the conclusion. Debates. People can agree on the same evidence but draw different conclusions because they don't accept the connecting logic. The paradox reveals the hidden burden in every argument, not just what we say, but how we move between ideas. Can it be resolved? Several approaches have tried to break the loop. A. Inference as implicit. Some philosophers argue that rules of inference, like modus ponens, aren't propositions, they're practices. We don't need to state them, we just use them. They are built into the act of reasoning. B. Meta-logic. Modern logic operates with layers. First-order logic handles basic statements. Meta-logic handles the rules about the rules. This structure allows us to assume inference rules without infinite regress, because the system distinguishes between levels. But Carroll's point still echoes. Even meta-logic assumes something. Final thought. The paradox of the tortoise and Achilles doesn't say that logic fails. It says that justifying logic with logic leads to an infinite regress. It reminds us that every rational system rests on unspoken rules. Rules we don't prove, but adopt. In the end, reasoning requires trust. Trust that the ladder of logic can bear our weight, even if we don't see the bottom. So Achilles may be swift, but in the end it's the tortoise, slow, methodical, paradoxical, who reveals the limits of motion and thought. The heap paradox. If one grain of sand doesn't make a heap, and adding just one more grain doesn't either, at what point does a heap become a heap? Can a heap disappear one grain at a time, yet never not be a heap? Welcome to the heap paradox, where the boundary between something and nothing dissolves under close inspection. Also known as the Sorites paradox, from the Greek Sorites, meaning heap, this problem dates back to ancient Greece and is often attributed to the philosopher Eubulides, a contemporary of Aristotle. The paradox was originally framed using vague predicates, terms like heap, tall or bald, and aimed to show the failure of logic when applied to concepts with unclear boundaries. At first glance, the paradox seems playful, even trivial, but its implications run deep into language, law, identity, and logic. Here's how the paradox works. Suppose you have a single grain of sand. No one would call this a heap. Now add another grain, still not a heap. Add one more, still not a heap. If we agree that one grain doesn't make a heap, and adding a single grain to a non-heap doesn't magically make it a heap, then we must conclude that no matter how many grains you add, it will never become a heap. But that's absurd. We all know that at some point you do get a heap. Maybe at 100 grains, maybe 1,000. We don't know exactly, but we know it happens. Here's the contradiction. Adding one grain doesn't make a difference. But repeating this harmless act many times eventually does make a difference. This challenges a fundamental assumption in logic, that small changes can't cause categorical shifts. The real puzzle. Vagueness. The heap paradox is an example of a vagueness paradox. Words like heap, bald, rich, and tall are vague predicates. They apply gradually, not sharply. How many hairs must you lose to be bald? How many dollars make you rich? How tall is tall? The problem is that natural language isn't designed for binary logic. Logic wants clear yes/no answers, but language and life is fuzzy. The paradox exposes the failure of traditional logic to deal with gradual transitions. Philosophical implications. 1. The problem of the cutoff. If we say there's a number, say 427 grains, where sand suddenly becomes a heap, we're forced to draw an arbitrary line, but nature rarely deals in clean lines. There's no objective difference between 426 and 427 grains, so why would one be a heap and not the other? This reveals a tension between our need for clarity in reasoning, the blurry reality we actually live in. 2. The paradox of Sorite reasoning. The logic behind the heap paradox leads to dangerous conclusions when applied to moral or legal reasoning. If stealing $1.00 isn't theft, then stealing $1 1,000 times. If lying once is harmless, what about 1,000 lies? The paradox warns us about the creeping power of incremental change. Modern responses and theories. Aepistemicism. Some philosophers argue that there is a sharp cutoff, we just don't know what it is. According to this view, there is a precise point at which a person becomes bald or a pile becomes a heap, but our epistemic limits prevent us from identifying it. B. Supervaluationism. This theory says that vague statements can be neither true nor false in some cases. Under this logic, this is a heap might be indeterminate. Not false, not true, but something else. This protects classical logic, but at the cost of semantic intuitiveness. C. Fuzzy logic. Fuzzy logic allows for degrees of truth. In this view, heap is not binary, it's a spectrum. 1 grain equals 0% heap. 50 grains equals 40% heap. 500 grains equals 95% heap. This approach models how people actually think and speak, but it abandons strict logic. D. Contextualism. According to this, whether something counts as a heap depends on context. In a desert, 20 grains might be a heap. In a sandbox, it might take 10,000. This allows flexibility, but also introduces relativism, applications in real life. Law. At what point does behavior become harassment? Medicine. How sick is too sick to work? Ethics. When does giving become exploitation? Politics. When does poverty become crisis? The heap paradox warns us that binary thinking can't capture the richness of human experience. Final thought. The heap paradox may seem like a word game, but it reveals one of the most profound truths about the world. Reality doesn't always play by the rules of logic. It reminds us that categories are human inventions, sometimes useful, sometimes deceptive. It shows us that big changes often come in tiny steps, and it teaches us to be humble with our definitions, cautious with our classifications, and mindful of the blurred boundaries that shape our lives. In a world built from grains of sand, perhaps the heap is not a thing, but a perspective. The paradox of the criterion. How can you know anything if you don't first know how to know? But how can you know how to know if you don't already know something? This is the paradox of the criterion, an ancient, invisible loop that questions the very foundation of all certainty. The paradox of the criterion was first formulated by the Greek philosopher Sextus Empiricus, a key figure in ancient skepticism, though the idea traces back to Pyrrho and Arcesilaus, early skeptics who questioned the very possibility of knowledge. The word criterion refers to a standard of judgment, a rule, method, or principle by which we decide what is true or false. But once you start questioning how we determine those standards, you tumble into a paradox that has haunted philosophy for over 2,000 years. Let's start with a simple question. Do you know anything for certain? To say yes, you must have used a method to determine that knowledge. Maybe reason, maybe evidence, maybe intuition. But how do you know that method is reliable? You must judge it, test it, compare it to something. But now you're in a dilemma. To know if a method is reliable, you need a standard, a criterion. But to know if that criterion is reliable, you need another standard to validate it. And so on, infinitely. This is the paradox of the criterion. To decide if something is true, you need a criterion. But to choose a correct criterion, you need knowledge. But to have knowledge, you already needed the criterion. So which comes first, knowledge? But how did you judge it without a standard? Criterion. But how did you select that criterion without prior knowledge? It's a vicious circle, a logical trap. No matter where you start, you need to already be at the finish. Philosophical breakdown. This paradox splits epistemologists into camps. 1. Methodism. Start with the criterion. This view says, let's first establish how we know. Then we can determine what we know. But critics ask, how do you judge a method without knowing anything first? 2. Particularism. Start with what we know. This says, we already know some things. Let's look at those and then figure out what method helped us get them. But then, how do you know those things are true without already having a method? 3. Skepticism. We can't escape skeptics, embrace the paradox. They say you can't justify either without the other, so we should suspend judgment entirely. In other words, certainty is an illusion. This skeptical position doesn't mean we should give up thinking, but that we should be aware of the limits of our foundations. Real-world implications. This paradox isn't just abstract, it underlies how we judge scientific claims, what counts as proof, who decides, evaluate media and truth. Is truth based on consensus, logic, emotion? Understand morality. Do we start from rules or from instincts and values? Whenever we ask, how do you know, we step into the paradox of the criterion, and it shows up in daily life. A teacher asks a student how they know the answer is right. A parent tells a child, because I said so. But what makes their authority legitimate? A citizen questions their government's rules, but who validates the validator? It's all the same loop. Attempts at resolution. Some philosophers and thinkers have proposed escape routes. A. Foundationalism. This theory says that all knowledge is built on certain self-evident truths, things that don't need a criterion. Examples, I think, therefore I am, or logical absolutes like A equals A. But foundationalism has critics. What's self-evident to one culture or person might not be to another. Even logic has been challenged across philosophical traditions. B. Coherentism. This theory abandons the search for a first step. Instead, it says that beliefs are justified when they form a coherent web. No one belief justifies all others, but together they support each other. It's like a raft. No plank holds it up, but all of them together float. But critics argue this might validate false systems, as long as they're consistent. Pragmatists like William James and Charles Peirce said, don't ask is it true, ask does it work. Knowledge and criteria are justified by their practical consequences. But skeptics warn, this risks confusing truth with usefulness. Final thought. The paradox of the criterion is the deep crack beneath every structure of knowledge. It humbles the philosopher, the scientist, and the skeptic alike. It whispers, you cannot truly prove your method without already trusting your method. It reminds us that every act of knowing begins in faith. Faith in reason, perception, intuition, or experience. And maybe that's not a weakness, but a necessary leap. Just like walking across a bridge you didn't build, believing it will hold. The paradox of analysis. What if defining something perfectly makes your definition completely useless? And if you define it in a way that's useful, it may no longer be accurate. This is the paradox of analysis, a strange loop in logic where clarity and insight clash. The paradox of analysis was introduced by G.E. Moore in the early 20th century, though it builds on earlier puzzles of language and meaning. The paradox found its formal name through discussions by later analytic philosophers like C.H. Langford, who sharpened its contradiction into a dilemma. At its core, it questions something we take for granted, the idea that we can analyze concepts clearly and meaningfully using other words. But when philosophers try to define even basic concepts like good, knowledge, or freedom, they found themselves trapped. The paradox would not let them go. Let's say we want to analyze a concept, like bachelor. We define it as an unmarried adult man. That seems right? Clear and accurate. But here's the paradox. If this definition is correct, then bachelor and unmarried adult man must mean exactly the same thing. And if they mean the same thing, then substituting one for the other tells us nothing new. Saying a bachelor is an unmarried adult man becomes like saying a bachelor is a bachelor. It's trivially true, but not informative. On the other hand, if the definition is informative, if it tells us something new, then it must not mean exactly the same thing, which implies it's not strictly correct. So you're stuck. If it's accurate, it's useless. If it's useful, it's inaccurate. This is the paradox of analysis. Analysis is at the heart of philosophy, mathematics, and science. We try to understand the world by breaking complex ideas into simpler ones, but this paradox suggests you can't analyze anything without either being redundant or being wrong. It shakes the foundations of analytic philosophy, which is built on precise examples of the paradox. Let's take another example, the concept of knowledge. Suppose we define knowledge as justified true belief. But when we examine the cases where someone has a justified true belief but still doesn't know, as shown in Gettyer's counterexamples, we realize the definition is informative but also incomplete. It leaves something out. If we made it truly equivalent to the word knowledge, then it wouldn't tell us anything. It would just repeat the term. So we want our definitions to enlighten us, but as soon as they do, they fail to be perfectly identical in meaning. Philosophical approaches. Several responses have tried to resolve the paradox. 1. Distinction between meaning and reference. Some philosophers argue that definitions can refer to the same concept without having the same meaning. So, bachelor and unmarried adult man refer to the same group of people, but the cognitive content of the terms is different. This allows analysis to be informative without being logically redundant. 2. Contextual definition. Another view suggests that analysis depends on context and background knowledge. When we define bachelor, it's not just about replacing one phrase with another, it's about teaching, clarifying, and understanding, which involves more than just logic. In this view, definitions aren't just linguistic, they're pedagogical tools. 3. Partial analysis. Some thinkers accept that no analysis is perfect. Instead of aiming for strict identity, they aim for approximations, partial analyses that capture aspects of meaning. This opens the door to continuous refinement, deeper implications. The paradox of analysis reaches beyond philosophy. In science, when we try to define life, force, or intelligence, we often fall into similar traps. In law, legal definitions must be exact, but also understandable and applicable. In AI, teaching machines human concepts requires definitions, but those definitions can oversimplify or distort. It also forces us to ask, can we ever truly know what we mean? Or are all our concepts clouded by interpretation, context, and infinite nuance? Final thought. The paradox of analysis is not just a technical puzzle. It's a mirror, showing us the limits of language and the gap between clarity and insight. It reminds us that definitions are not windows, they are scaffolding. We use them to build understanding, but the higher we climb, the more we see that the structure was just temporary. True understanding may not lie in defining, but in living with ambiguity and growing into meaning. Perhaps the best analyses are not final answers, but invitations to deeper inquiry. The Sleeping Beauty paradox. You wake up in a room. You've been part of a strange experiment, but you don't remember what day it is. Now you're asked, what is the probability that the coin flipped on Sunday landed heads? You think you know the answer, until logic starts to unravel. The Sleeping Beauty paradox was first formally introduced by Arnold Zuboff in the 1980s and became a mainstream philosophical problem after being popularized by Adam Elgar in 2000. Though it sounds like a fairy tale, this paradox is one of the most debated probability puzzles in modern epistemology, philosophy of mind, and decision theory. It deals not just with randomness, but with self-locating belief. Your knowledge of your place in time. Here's the setup. On Sunday, Sleeping Beauty is told the following. A fair coin will be flipped. If the coin lands heads, she will be awakened once on Monday, then the experiment ends. If it lands tails, she will be awakened on Monday and again on Tuesday. After each awakening, she will be put back to sleep and her memory of waking will be erased. When she wakes up, she doesn't know what day it is, whether the coin landed heads or tails. Now, the question is, when Sleeping Beauty wakes up, what should be her credence, degree of belief, that the coin landed heads? Why? Let's count the number of times she could wake up. If heads, she wakes once, Monday. If tails, she wakes twice, Monday and Tuesday. So, across many repetitions of the experiment, 1 out of 3 total awakenings follow a heads result. 2 out of 3 follow a tails result. So upon waking, the odds are 1-2 in favour of tails, discouraging most fast. 1/3 heads/3 tails. This view is supported by decision-theoretic arguments and is favoured by most philosophers. 2. The Harford position Sleeping Beauty should assign a 1/2 probability to heads. Why? The coin is fair. The setup occurs before any memory erasure or awakenings. She gains no new information about the coin once she wakes. From her perspective, she knew on Sunday what would happen. Waking up was guaranteed no matter the result. Therefore, nothing has changed, still 1/2. This approach is supported by Bayesian reasoning and traditional probability. Where it gets weird, this paradox forces us to question the very nature of evidence and belief. Has Sleeping Beauty learned anything upon waking? Should the number of possible experiences influence her belief about past events? Is she reasoning from a God's eye view or from inside the story? It gets even more tangled when we consider decision-making. If offered a bet with favourable odds on heads or tails, how should she act? Should our beliefs change depending on how many versions of us exist? The paradox also ties into theories about cloning and duplication, simulation theory, anthropic reasoning, reasoning based on the fact that you are an observer, broader implications. This puzzle stretches far beyond a sleeping woman and a coin. It touches philosophy of consciousness. What does it mean to be a self at a particular time? Artificial intelligence? How should a machine update beliefs when its memory is wiped? Physics and cosmology. In multiverse models, should we assign higher probability to worlds with more copies of ourselves? It even echoes existential questions. If you don't know when or where you are, how much can you really know at all? Possible resolutions. There's no universal agreement. Some variations try to alter the setup, asking, what if the coin isn't fair? What if she remembers the first awakening but not the second? What if the experiment is repeated over a long span of time? Others suggest we need entirely new systems of probability to handle self-locating belief. Final thought, the Sleeping Beauty paradox is a riddle about belief in isolation. Belief without memory, without time, without anchor. It makes us ask, how much of what we believe depends not on the facts but on when and where we find ourselves? In a way, we are all Sleeping Beauty, waking up into a world without knowing the full story. And perhaps the real question is not what the coin says, but how much trust we place in the limits of our knowledge. The paradox of suspense. You've watched the same movie 5 times. You know the hero survives, and yet your heart still races, your palms still sweat, and the tension still builds. How can you feel suspense when you already know what's going to happen? The paradox of suspense was brought into philosophical focus by thinkers like Kendall Walton and Noel Carroll, who questioned how audiences can experience genuine suspense when they already know the outcome of a story. This paradox sits at the crossroads of aesthetics, emotion and cognition, and it's something every moviegoer, reader and gamer has felt. Why do we grip the armrests, even during a rerun? Here's the contradiction. Suspense, by definition, requires uncertainty. But if you've seen the story before, or if it's a widely known tale, you already know the ending. So if there's no uncertainty, how can you still feel suspense? Take an example. You're rewatching Titanic. You know the ship sinks. You know Jack dies. And yet, every time the music swells, every time the iceberg looms, you find yourself emotionally invested, even anxious. This doesn't make sense under a strict logical view. If suspense depends on not knowing, then rewatching a story should eliminate suspense. But it doesn't. Why? The theories that try to explain it: 1. Forgetfulness or misremembering. Some say we forget small details over time, so we're not 100% sure what happens next. But this doesn't explain watching the same film twice in a week or rereading a well-known classic like Romeo and Juliet. We still feel suspense. 2. Emotional simulation. Others argue that we pretend we don't know the outcome. We suspend disbelief, stepping into the shoes of a first-time viewer. This is called emotional simulation. We choose to play along, much like we fear a haunted house we know isn't real. But this still raises a deeper question. Why is our emotional mind willing to play along, even when our logical mind knows the truth? 3. Fictional truth versus real knowledge. Another explanation draws a line between real-world knowledge and fictional experience. In fiction, the truth is defined within the story. Even if you, the viewer, know the end, the characters don't. Your empathy locks into their uncertainty, not your own. So the suspense isn't about you not knowing, it's about them not knowing. You feel what they feel. This creates a kind of second-hand suspense, not about the ending, but about the experience of getting there. Layers of suspense. The paradox also reveals that suspense isn't just binary, know or not know. It's layered and psychological. You may know what happens, but not how. You may anticipate when something will happen, but still feel tense waiting. You may feel suspense from the emotion, not the event, hoping that this time, somehow, things will change. This is especially true in tragic or doomed stories. Even when you know the worst is coming, your heart hopes for an escape, and the clash between what you know and what you want fuels the suspense. The paradox in real life, it's not just fiction. A parent waits for a child's surgery to end. Even if the doctor says it's routine, a teacher watches a student approach the final exam, knowing they've done everything possible to prepare. You wait for a call you already know the outcome of. Suspense is not always about ignorance. Sometimes it's about caring deeply, even in the face of certainty. Philosophical implications. The paradox of suspense challenges how we understand emotion versus cognition, truth versus engagement, experience versus logic. It reminds us that we are not purely rational beings. We can hold knowledge and emotion at once, even when they contradict. It also points to something beautiful. We can feel suspense, not because we're confused, but because we are alive inside a story, again and again. Final Thought's suspense isn't broken by knowledge, it's built on empathy, anticipation, and emotional immersion. The paradox of suspense reveals that being human is not about having all the answers. It's about how we feel, even when we do. So the next time your heart pounds during a movie you've seen 10 times, don't ask, why am I scared? Ask instead, how amazing is it that I still care this much, knowing exactly what's coming? The paradox of tragedy. Why do we love stories that make us cry? Why do we willingly watch tragedies, knowing they'll leave us broken inside? If pain is something we try to avoid, why does it feel so beautiful in fiction? The paradox of tragedy goes back to the dawn of drama itself. Even Aristotle, writing in the 4th century BCE, wrestled with this question in his Poetics. He observed that audiences found pleasure in tragic plays, even when the events depicted were horrifying. From Oedipus Rex to Romeo and Juliet to Schindler's List, the question persists: how can we be moved by suffering and call it enjoyment? Here's the contradiction. Tragedy causes sadness. Sadness is an unpleasant emotion, but we seek out tragedies voluntarily and often love them. In daily life, we avoid grief. We fear loss, injustice, and suffering. But in stories, we embrace heartbreak. We watch lovers separated, heroes die, children suffer, and we feel something deep, and then we call that experience rewarding. This paradox strikes at the core of human emotion. What are we really enjoying? Philosophers have offered different theories to explain this emotional contradiction. 1. Catharsis. Aristotle believed tragedy provided a safe space to purge emotions like fear and pity. When we experience intense sorrow in fiction, it releases us. Like a storm passing, we emerge cleansed. This is why tragedy feels satisfying. It offers emotional resolution. But this doesn't fully explain why we'd seek out more sadness later. 2. Meta-emotions. Some argue we enjoy the feeling of feeling. We're not just sad. We're moved, touched, deeply human. You cry at a scene, not because you're in pain, but because you're experiencing empathy, beauty, or moral truth. So the emotion isn't pure grief, it's layered, with awe, connection, even joy. 3. The aesthetic distance. Another view says that fiction provides a safe frame. We know the tragedy isn't real, so we can explore dark emotions without threat. This distance lets us engage without being overwhelmed. We feel sadness, but we are not in danger, so we can savor the sorrow. 4. The appreciation of truth tragedy often reveals deep truths about loss, sacrifice, injustice, love. It confronts us with the fragile beauty of life. We admire the honesty, the rawness, the existential weight. It doesn't feel good, it feels real. And that reality is something our souls crave. Modern examples. Think about Titanic, a doomed love story wrapped in historical disaster. Grave of the Fireflies, animated but devastating in its depiction of war. The Green Mile, where justice and compassion collide. Or the countless songs, poems and books that pierce us with sadness, and yet we revisit them again and again. We don't just tolerate these emotions, we seek them. Why? Because tragedy offers something ordinary joy cannot. Depth. A thought experiment. Imagine a world where every movie had a happy ending. Every character survived. Every story ended in celebration. Eventually, we'd grow numb. Tragedy reminds us that life is precious because it's fragile. The hero's death means something because it didn't have to happen. The loss of love is only tragic because it once felt eternal. Without darkness, light loses meaning. Why the paradox matters. The paradox of tragedy isn't just about movies or plays. It's about how humans find meaning in suffering. We hold funerals that both mourn and celebrate. Read memoirs about grief to feel less alone. Listen to sad music when our hearts are broken, not to escape pain, but to embrace it. It shows that emotion is not binary. We can feel sad and satisfied, broken and whole all at once. Final thought. The paradox of tragedy teaches us something profound. We are not made to avoid pain. We are made to understand it, transform it, and sometimes even cherish it. That's why tragedy moves us. It doesn't promise a happy ending. It promises a true one. In a world obsessed with constant pleasure, tragedy reminds us that sometimes the tears we cry are not weakness, but a witness to what it means to be fully alive. The paradox of fiction. You sob when a fictional character dies. You feel fear when the villain appears. But deep down, you know none of it is real. So how can we feel real emotions for people and events we know are completely made up? The paradox of fiction was formally introduced by philosopher Colin Radford in the 1970s. His paper, How Can We Be Moved by the Fate of Anna Karenina, laid out the contradiction clearly. Radford's argument sparked a storm of philosophical debate, bringing attention to how deeply and strangely we interact with fictional worlds. Here's the puzzle. We can only feel genuine emotion toward things we believe are real. When we engage with fiction, we know it's not real, yet we feel genuine emotions, grief, joy, love, fear, for fictional characters and events. So what gives? Let's make it concrete. You cry when Tony Stark dies. You cheer when Harry Potter defeats Voldemort. You panic when a horror movie monster steps into frame, but the rational part of your brain knows none of this is real. These people don't exist. So why do you feel anything at all? According to the paradox, one of those three statements must be wrong, and whichever one you reject changes everything about how we understand emotion. The theories that try to resolve it. 1. The pretense theory. Some philosophers, like Kendall Walton, say we're not really feeling emotions, we're pretending to feel them. When you cry at a movie, you're playing a game, just like children do when they pretend their stuffed animal is hurt. This is called make-believe emotion. It looks real, but it's just a performance. But here's the issue. the pain still feels very real. If it's all pretend, why does it linger after the credits roll? 2. The thought theory. Another idea is that emotions can arise just from thoughts, not beliefs. You don't have to believe something is true, you only have to imagine it vividly enough. Think about nightmares. You wake up sweating, terrified, heart pounding, no belief involved, just imagination. So in fiction, we might feel real emotion from unreal thoughts. This idea allows for emotions without commitment to truth. 3. Emotional reprogramming. Some argue that fiction trains our emotional system to respond as if it were real. We evolved to learn through stories, so even if the characters aren't real, the situations feel real, and that's enough to trigger authentic emotion. Your brain is wired not for truth, but for meaning, fiction and empathy. Here's where the paradox becomes even more profound. We feel emotions for people who never existed, but often we feel them more deeply than we do for real people. You might mourn the death of a character more than the news of a stranger dying across the globe. This raises difficult questions. Are fictional characters more emotionally available to us than real ones? Does fiction make us more empathetic or less? Are we escaping reality or deepening our relationship to it? Fictional truths. Fiction is full of emotional truths, even when the facts are false. A story may be invented, but the human experiences it conveys are real. We cry not because Frodo exists, but because his struggle mirrors something in us. We cheer not because Katniss is real, but because hope feels real when she rises. So, perhaps, emotion doesn't require factual reality, it only requires emotional resonance. Final thought. The paradox of fiction shows us that we are creatures made not just of facts, but of feeling. Our minds know what's real, but our hearts follow something deeper. Something symbolic, imagined, transcendent. And maybe that's not a flaw. Maybe it's what makes us human. We are the species that weeps for ghosts, cheers for myths, and finds truth in tales that never happened. Fiction isn't a lie, it's a mirror. And sometimes it shows us more clearly than the real world ever could. The paradox of hedonism. You chase pleasure to be happy. You structure your life to feel good, to enjoy every moment. But the harder you chase happiness, the further it seems to run. Why does seeking pleasure directly make it harder to find? The paradox of hedonism was first articulated by Henry Sidgwick in the 19th century and expanded by philosophers like John Stuart Mill. Though the idea is ancient, echoed by the Epicureans and Stoics, modern psychology has turned this philosophical insight into a widely studied truth. Sidgwick observed that people who make pleasure their primary goal rarely achieve it. The paradox goes like this. If happiness is your only aim, you're unlikely to find it. But if you pursue something else, love, meaning, creativity, happiness often sneaks in as a side effect. Let's break it down. Imagine a man named Sam. Sam decides to dedicate his life to one thing, feeling good. He eats the best food, travels for comfort, seeks only fun people and easy experiences, avoids anything painful, uncomfortable, or difficult. At first it works. Life feels light, free, pleasurable, but slowly something shifts. The joy from his meals fades. The thrill of new places becomes repetitive. The relationships feel shallow, and worst of all, he starts feeling empty. The very life built to maximize happiness has now left him bored, restless, and unsatisfied. This is the paradox of hedonism. Why it happens. 1. Happiness is a byproduct, not a target. Happiness doesn't respond well to direct pursuit. It's like trying to fall asleep. The more you focus on it, the harder it gets. Philosopher Viktor Frankl said, "Happiness cannot be pursued, it must ensue, as the unintended side effect of one's dedication to a cause greater than oneself. When you immerse yourself in purpose, love, or service, joy often follows. But when you aim at joy itself, it slips through your fingers." 2. Pleasure diminishes with repetition. This is called hedonic adaptation. Our brains are wired to normalize pleasure. The first bite of chocolate is magical. The 10th, barely noticeable. When you seek only pleasure, your brain adapts, fast. The result? You need more and more just to feel the same. Chasing pleasure becomes a treadmill. You're running faster, but going nowhere. 3. Shallow goals versus deep fulfillment. Pleasure is often surface level. Fulfillment, meaning and connection lie deeper. A life built only on pleasure ignores the parts of life that grow us. Struggle, responsibility, risk, sacrifice. Ironically, the moments that feel hard often lead to the deepest long-term satisfaction. Modern psychology confirms it. Studies show that people who value meaning over pleasure report higher life satisfaction, more resilience, deeper relationships, less depression and anxiety. They still enjoy life, but joy is a consequence, not the goal. Conversely, those who chase pleasure often end up feeling lonely, numb, disconnected, chronically unsatisfied. Pleasure is not the enemy, but when it becomes the main course instead of the spice, life becomes unbalanced. A real-life example: consider artists, athletes, scientists. They often suffer through practice, endure criticism, delay gratification. Yet in those struggles, they find joy, purpose, flow. They don't chase pleasure directly, they chase excellence, growth, contribution, and happiness follows. Meanwhile, the person who only seeks entertainment may find life slowly losing color. Final thought: the paradox of hedonism is a compass pointing us toward a deeper truth. Joy doesn't live where you think it does. It lives in presence, connection, and meaningful pursuit. The happiest people often aren't trying to be happy, they're trying to live well. And in that effort, in that messy, honest, wholehearted living, happiness arrives, not as a guest you summoned, but as a companion who walks beside you when you least expect it. So if happiness is what you seek, don't aim at it, aim at something worth doing, and let happiness come find you. It's the paradox of tolerance. If you believe in total tolerance, should you also tolerate the intolerant? But if you do, doesn't that allow intolerance to destroy tolerance itself? Where do we draw the line between freedom of thought and protecting it? The paradox of tolerance was first clearly articulated by philosopher Karl Popper in his 1945 book, The Open Society and Its Enemies. Popper, reflecting on the horrors of World War II and the rise of fascism, raised a fundamental question. Can a tolerant society survive if it tolerates intolerance? This wasn't just a theoretical musing, it was born from history, where regimes that rose in the name of free speech ended up crushing it once they held power. Let's break the paradox into its core contradiction. A tolerant society values freedom of expression and belief. Intolerant ideologies seek to suppress or eliminate opposing views. If a tolerant society tolerates intolerance, it may enable its own destruction. So the dilemma is, to preserve tolerance, must we become intolerant of intolerance? That sounds like hypocrisy, but is it? Let's look deeper. The open door dilemma. Imagine a house with an open door policy. Anyone is welcome as long as they respect the home. Now a guest enters and says, "This house should be mine. Everyone else should be kicked out." If you allow that guest to stay and speak freely, soon they may convince others. They grow louder. They bring allies. Eventually, they take control and shut the door behind them. Your open door policy was used against you. That's the paradox. Tolerance, if unlimited, can be the seed of its own undoing. Real-world examples. History is filled with chilling reminders of this. Nazi Germany rose during the democratic Weimar Republic. Hitler used free speech and assembly to gain influence, and then abolished those rights once in power. Extremist groups around the world have used open platforms to radicalize, manipulate, and eventually silence dissent. Tolerance is fragile. It's not just a virtue, it's a system that requires protection. Popper's clarification. Popper didn't suggest silencing every view you disagree with. He made an important distinction. We should tolerate all, except those who are intolerant and unwilling to engage in reasoned dialogue. If someone promotes violence, hate, or seeks to shut down open conversation, they're not just offering an alternative view. They're attempting to erase the foundation that makes conversation possible. Is that still tolerance? This leads to a deeper philosophical challenge. If we silence intolerant speech, are we becoming intolerant ourselves? Perhaps. But Popper argues this is a necessary contradiction. Just as a body uses its immune system to protect itself, a society must have defenses, not to suppress ideas, but to preserve the environment where ideas can thrive. It's not about censorship, it's about boundaries. Boundaries aren't the enemy of freedom, they are what make freedom possible. The modern context. Today, this paradox plays out in real time. Online platforms wrestle with whether to host hate speech. Governments debate how far free expression should go. Communities question when to speak out. and when to shut something down. Tolerance isn't a passive act. It's an active commitment to fairness, inclusion, and shared humanity. And sometimes that means saying, no, we will not tolerate the voices that seek to silence others. Final thought. The paradox of tolerance reminds us, a free society is not just about letting everyone speak, it's about protecting the space where everyone can speak safely. Unconditional tolerance is not peace, it's passivity. And passivity can become complicity. So yes, tolerance has a boundary, and that boundary is drawn at the point where tolerance is attacked. If we want to keep the doors open for all, we must sometimes close them to those who would burn the house down. The paradox of value. Water keeps us alive, diamonds don't. And yet diamonds can cost thousands, even millions, while water, something we literally cannot survive without, is often taken for granted, priced at just a few coins or even free. Why? If value is tied to how important something is, shouldn't it be the other way around? This unsettling contradiction, known as the paradox of value, or the diamond-water paradox, goes back centuries. It puzzled some of the greatest minds in philosophy and economics. Even Plato hinted at this tension between necessity and perceived worth. But it was Adam Smith, in his groundbreaking 1776 work The Wealth of Nations, who fully articulated it. He wrote, "Nothing is more useful than water, but it will purchase scarce anything. A diamond, on the contrary, has scarce any value in use, but a very great quantity of other goods may frequently be had in exchange for it." This contrast shook thinkers of the time. Smith, for all his insight, left this puzzle unsolved. Why does the market reward what's flashy more than what's foundational? Why does a symbol of love cost more than the substance of life? The resolution would come later, through the emergence of modern economics and a deeper understanding of human psychology. To unravel this paradox, we need to ask a basic but powerful question. What do we actually mean by value? At first glance, value seems simple. Something is valuable if we need it, right? But economics splits value into two distinct concepts. Use value, how useful or essential something is. Exchange value, what someone is willing to trade or pay for it. Water has immense use value. It hydrates us, cleanses us, powers industry and agriculture. We die without it in days. Diamonds, by contrast, have almost no use value. They don't feed us, shelter us, or heal us. Their industrial use is minimal, and yet they fetch sky-high prices on the market. So how can something so unnecessary have such great exchange value, while something so crucial is dirt cheap? The answer comes from a brilliant shift in perspective. Led by thinkers like Carl Menger, William Stanley Jevons, and Leon Walras in the 19th century. They introduced a radical concept that changed economics forever: marginal utility. Here's the key. We don't value goods in absolute terms. We value the next unit of a good, what we call its marginal utility. Imagine you're stranded in the desert. You've had no water for 2 days. A bottle of water appears. That first bottle, priceless. You trade anything for it. The second, still life-saving. But the 10th, less important. The 100th, you may not even want it. Now picture diamonds. You rarely come across one. They're rare, symbolic, and socially powerful. So when one appears, its perceived utility, even though not practical, is immense. In modern societies, water is abundant. It's everywhere. So the marginal utility of the next glass of water, low. Diamonds, scarce, tightly controlled, beautifully marketed, though their marginal utility stays high. The market doesn't care how useful something is in principle, it cares how much people want one more unit of it right now, subjective value. The paradox also uncovers something uncomfortable about human nature. Value is not rational. It's emotional, cultural, and subjective. We don't pay based on what's necessary. We pay based on what makes us feel powerful, beautiful, or loved. Diamonds carry symbolic weight. They represent commitment, luxury, prestige. They're rare and hard to obtain. Their sparkle captures the imagination. Water? It's basic, unremarkable, common. And this reveals something deeper. Our economic systems often reward not need, but desire. That desire is shaped by marketing, culture, and perception, not by practicality. Modern ironies. Let's put this paradox in today's context. In a mall, someone spends $20,000, 0 cents, on a diamond ring without a second thought. Outside, a homeless person searches for clean water. The irony is stunning. One is a symbol, the other is survival. It gets darker. Bottled water, one of the most abundant substances on Earth, has become a multi-billion-dollar industry, while billions around the world still lack access to safe drinking water. This isn't just a paradox, it's a moral contradiction. Philosophical implications. The diamond water paradox doesn't just challenge economists, it forces all of us to reconsider our relationship with worth. Do we mistake price for importance? Do we neglect the ordinary blessings around us simply because they're everywhere? Do we pay more for things that look good than things that do good? This paradox is a mirror. It shows a society dazzled by scarcity and blind to abundance. A world where things that sparkle are exalted while things that sustain are ignored. Beyond economics, a shift in thinking. We often forget, price is not truth. The market reflects what people believe something is worth, not what it's truly worth, and that belief can be manipulated. The diamond industry, for example, thrives on artificial scarcity and masterful advertising. De Beers, a company that once controlled over 80% of the diamond supply, marketed the idea that a diamond is the ultimate sign of love. Their slogan, "A diamond is forever." That line wasn't philosophy, it was strategy. Meanwhile, water, though the foundation of all life, is sold, wasted, polluted, and underappreciated. Final thought. The paradox of value teaches us a quiet, powerful lesson. What's valuable is not always valued, and what's valued is not always valuable. We must learn to see beyond price tags, to recognize that the things we rely on most, the air, the water, the earth, the care of others, are often the cheapest, but the most precious. It challenges us to build a world where value is not just measured in currency, but in consequence. Because when the taps run dry and the glitter fades, we'll remember that diamonds may be forever, but without water, we are not. The paradox of voting. What if I told you your vote doesn't matter, and yet democracy cannot function without it? What if millions of rational individuals acting logically all chose not to vote because it's just one vote? That's the paradox of voting, where reason says don't bother, but morality, society, and democracy scream, you must. The paradox of voting, sometimes called Downs' paradox after economist Anthony Downs, was first described in 1957 in his book An Economic Theory of Democracy. It's a problem that arises when we apply rational choice theory, the idea that individuals make decisions by weighing costs and benefits, to the act of voting. Here's the kicker. From a purely selfish, cost-benefit perspective, voting almost never makes sense. You spend time to register, you wait in line, you research candidates, you take time off work or rearrange your day. And for what? A vote that is almost guaranteed not to change the outcome. Statistically, the odds that your vote will decide a national election are astronomically low. For example, in a US presidential election, the odds are often cited as being somewhere between 1 in 10 million and 1 in 100 million. So if you're thinking rationally, why vote? And yet, millions do. This paradox sits at the intersection of logic, civic duty, psychology, and morality. Let's break it down. According to strict rational choice theory, expected benefit of voting equals probability your vote is decisive, X. Benefit of your preferred candidate winning. Given the extremely low probability of your vote being decisive, the expected benefit is virtually zero. The cost, meanwhile, your time, your effort, is real. So, if you're acting in your own self-interest, the rational decision is to not vote. But what if everyone thought that way? Democracy collapses. If every individual acting rationally decides their vote is meaningless, then no one shows up. The whole system, built on participation, crumbles under the weight of its own logic. This is the paradox. Voting is irrational for the individual, but essential for the group. The collective action problem. The paradox of voting is a collective action problem, just like climate change, public goods, herd immunity. It's irrational for one person to act, but if no one acts, we all suffer. In this case, the public good is democracy itself, a functioning system that reflects the will of the people. It requires participation to exist. Your vote may not matter by itself, but without votes, there's no democracy at all. Why people still vote? So why do people vote, despite this logic? Here's where it gets interesting. 1. Civic duty. Many people vote out of a sense of responsibility, not self-interest. They believe it's their moral obligation to participate. Voting becomes a matter of ethics, not calculus. 2. Expressive voting. Some vote not to change the outcome, but to express their identity or support their values, like cheering for your team even when they're losing. You're signaling who you are. 3. Social pressure. Voting is socially encouraged. People don't want to be seen as apathetic or irresponsible. In some cases, they're literally asked, "Did you vote?" And not voting feels like a failure to contribute. 4. Psychological bias. Humans often overestimate their own importance. We think, deep down, well, maybe it'll come down to my vote. This optimism bias fuels action, even when logic says otherwise. The paradox deepens. Let's take it a step further. Say you believe your vote won't matter. So you don't vote. Now imagine thousands of people feel the same, and because of that the outcome swings by a margin that could have been closed by just a few hundred votes. Suddenly, you weren't just wrong logically, you were part of a self-fulfilling prophecy. This is the strange world the paradox of voting creates. If enough people believe their vote doesn't matter, they create the very conditions where votes actually do. What democracy requires. Democracy is built not on perfect logic, but on a leap of faith. It requires people to act as if their voices matter, because when enough of us do, they actually do. That's the beauty of the paradox. It reveals that democracy is not just a system, it's a belief, and belief is powerful. It's the same force that gets people to fight for rights, stand in the rain at polling stations, and inspire generations with slogans like "Every vote counts." Because while a single vote may be statistically tiny, it represents something enormous, a commitment to being part of something bigger than yourself. Philosophical echoes. The paradox of voting is also a mirror to other life decisions. Should I recycle if others don't? Should I tell the truth if it's easier to lie? Should I stand up to injustice if no one else will? In each case, your action may seem insignificant in isolation, but when multiplied it becomes transformative. Voting, then, is not just a political act. It's a moral gesture. It says, I matter, and even if the odds are low, I will speak anyway. Final thought. So yes, your vote is unlikely to decide an election. And yes, by the numbers, it's a terrible investment of time. But life is not just about winning bets. It's about showing up. Because if enough people stop showing up, we don't just lose elections, we lose democracy itself. So next time someone tells you voting doesn't matter, ask them this: if your voice truly didn't matter, why have so many fought to silence it? The paradox of voting doesn't ask us to be perfectly logical. It asks us to be bravely committed, because some of the most important things we do aren't rational. They're necessary. The Abilene paradox. Imagine this. You're sitting with friends on a hot afternoon, and someone suggests a long, uncomfortable drive to a dusty town with bad food. Nobody really wants to go, but no one speaks up. You all go, and all of you hate it. Later, everyone admits, I thought you wanted to go. That's the Abilene paradox, where groups do things no one actually wants. The Abilene paradox was introduced in 1974 by Jerry B. Harvey, a professor of management science at George Washington University. In his essay, The Abilene Paradox, The Management of Agreement, Harvey recounts a personal anecdote that became the cornerstone of this paradox. On a sweltering Texas day, he and his family were sitting comfortably on a porch. Suddenly, his father-in-law suggested driving 53 miles to Abilene for dinner. The others agreed, reluctantly. They drove through the heat, ate bad food, and drove home exhausted. Then came the twist. Each family member confessed they hadn't wanted to go. They only agreed because they thought the others were enthusiastic. Nobody wanted to go to Abilene. Yet, they all went. The Abilene paradox is not about conflict, it's about false agreement, where people do things against their own desires because they assume others want it. It reveals something deep and unsettling about group dynamics. People often act against their best judgment not out of pressure, but out of assumption. Let's explore how it unfolds. Someone proposes an idea, perhaps just as a suggestion. Others nod or agree, not because they want to, but because they don't want to rock the boat. No one voices objections. The group takes action. Afterward, they all realize no one actually supported the decision. It's not a failure of communication. It's a failure of honest communication. This paradox plays out everywhere. In boardrooms, when a company pursues a doomed project. In friend groups, when no one wants to attend a party, but they all go. In families, where holidays are planned that exhaust everyone. Everyone is trying to avoid conflict, but ends up creating misery. Why does this happen? At the heart of the Aberlane paradox is a deep human fear. The fear of disapproval, disruption, and being the outlier. We are social creatures. We value harmony, and often we assume that dissent equals confrontation. So instead of saying, actually, I'm not sure I want to go, we say, sure, if that's what you guys want. This desire to avoid discomfort creates a loop of silence. Each person becomes a mirror, reflecting what they think the others feel. No one breaks the illusion, so the illusion becomes reality. The role of leadership. In organizations, the Aberlane paradox can be devastating. Projects move forward without real buy-in. Bad ideas are approved. Teams follow plans they secretly question. Leaders who fail to create safe spaces for dissent unintentionally encourage this paradox. A wise leader knows agreement, enthusiasm, silence, support, consensus, clarity. The best leaders actively invite disagreement, reward honesty, and normalize the phrase, I'm not sure this is the right move. Can we talk about it? Psychological drivers. Several psychological forces feed this paradox. 1. Pluralistic ignorance, where everyone in a group privately rejects a norm but believes others accept it. 2. Social conformity. We're wired to fit in. Going against the group feels risky. 3. Fear of conflict. We avoid raising concerns to keep things smooth, even when the truth is bubbling underneath. 4. Projection. We assume others are more enthusiastic than they really are and adjust ourselves accordingly. Real-world examples. Corporate decisions. Entire companies have invested billions into products no one internally believed in because no one wanted to be the one who said no. Family events. Think of the holidays you spent traveling or hosting under stress, only to hear everyone afterwards say, next year, let's not do that again. Politics. Laws and policies can pass without popular support simply because dissenters think they're alone. The cost of not speaking up. The Aberlane paradox is about more than bad dinners or awkward meetings. It's about the long-term consequences of living inauthentically. Projects fail, time is wasted, resentment builds, trust erodes. Each time we betray what we want because we fear the ripple effect, we give up a bit of agency. Silence may keep the peace in the moment, but over time it creates decisions nobody owns, breaking the paradox. Escaping the Aberlane paradox requires courage and a new way of relating to groups. Here's how. 1. Check assumptions. Don't guess what others want. Ask. Clarify. Invite honesty. 2. Normalize dissent. Make it safe to say I disagree without fear of being labeled difficult. 3. Watch for signals. Sometimes body language or quiet hesitation speaks louder than yes. 4. Be the first. Sometimes it just takes one person to say, actually, I'm not up for this. That vulnerability can open the floodgates to truth. Final thought. The Aberlane paradox is not about stupidity or sabotage. It's about kind people trying to please others and accidentally creating outcomes no one wants. It reminds us, the enemy of good decisions isn't disagreement, it's false agreement. Speak your truth, even when it's awkward. Because the moment you say, I'm not sure I actually want this, you give others permission to be real too. And in that space, honest, messy, human, you'll find the clarity that makes group decisions not just smarter, but truly shared.